Hello students, welcome to this live discussion. I know many of you are preparing for boards and it might be difficult for many of you to attend this live, but as mains is also approaching, so we have to take care of that also. In April attempt, we had 10 papers. Now, I'll ask all the students to go through them, but as time is the constraint, okay, it may not be possible for all the students to go through all the 10 papers because in physics we have 250 questions, in chemistry we have 250 questions, in maths we have 250 questions. Overall we have 750 questions. Now it may be difficult for all the students to complete all those questions, but in this live I have selected all the important questions from set of 250 questions. All the important questions are selected, so we are going to discuss that. And yes, this is very important because anyways April attempt is approaching, you have to appear for that. Many of you want to improve your percentile, so at least you should know what type of questions were asked in January attempt, okay, which all the key things that should be kept in mind that we are going to discuss here. So let us begin with the first question. So we will go chapter wise chapter, okay. So we are starting from units and measurements, covering the 11th portion, and then we'll go to the 12th portion. The time period of simple pendulum oscillator is given like 2 pi root m by k. In the actual paper, I think this was given as k by m, but anyways, that will not change the answer. Measured value of mass of the object is 10 gram with an accuracy of 10 milligram. 10 milligram means that is my delta m. And time for 50 oscillations of the spring is found to be 60 seconds using a watch of 2 resolution second. It means this 2-second error is in 60 seconds. Now percentage error in determination of spring constant is. So first of all, from this relation we'll write what is delta k by k like that, okay, relating with delta t by t and delta m by m. So I can say from here that my t square is basically equals to 4 pi square into m by k. K we will take on the left, so k is coming out to be proportional to m by t square. Now 4 pi square is anyways constant, okay, so we are not considering that part in the error. So from here if I write delta k by k, so delta k by k will be equal to delta m by m plus 2 delta t by t. Why plus? Because we are finding the maximum error. Now what is delta m? Delta m is 10 milligram, m is 10 gram. So when I write delta m, that is 10 milligram, okay, so 10 into 10 to the power minus 3 grams divided by m, that is 10 gram, like this, plus 2 into delta t by t. Now don't think like, you know, this is the time period of how many oscillations? 50 oscillations. So we should find the time period of one oscillation and that we should put here, and accordingly we will find delta t there. No, don't do like that. Doesn't matter whether this time is for one oscillation or it is for 10 oscillations. I just need how much percentage error is there in measurement of t. So when I am measuring 60 seconds, the error is 2 seconds. So delta t is 2, t is 60. Okay, that thing is there. So don't convert that to, you know, by time period of one oscillation and like that. That is not needed. Into 100. Into 100 we are doing both sides to find the answer in the percentage. Thank you. Now just some calculations from here. Let us do that. So this will become 0.1 plus 4 by 60. So this is 15. So 100 by 15. 5 into 3, 5 into 20, 6.67 plus 0.1. So this is 6.77% nearly. 6.77. I think there is some typing mistake. This is 3.35, 3.35. Okay, it should be 6.67. Third option. Okay. Next question, another question. Now matrix match kind of thing are asked from units and measurements. many times. I think in April attempt there were some dimensions from magnetism chapter also, like magnetic dimension, mu naught is there, epsilon naught is there, okay, electric field, magnetic field, all those type of things. And here we are having few more things, spring constant, thermal conductivity. Let us do that. Spring constant, we know force is equals to kx. So from here if I say that the k will have the unit of F divided by the unit of x. So if we write the dimensions, what it will be, mlt minus 2 for force divided by L. So this will become mt minus 2. mt minus 2, that is second option. For A we are getting second. Next is thermal conductivity. Now use any of the formula that you know for thermal conductivity. We know power, that is Ka dt by dx. Certainly a negative sign is there, but we will not consider because just we need the dimensions and all. So from here I can find the dimensions of K. So K will have the dimensions of power divided by area into this dx is my length, I can write this as length, and here this T is temperature, capital T. This area is length square, so one length will be here. And now what is power? Power is energy by time. So this is mL2 T minus 3. T minus 2 is energy by time, so T minus 3 divided by this length which is L, this T, this is Kelvin, because that is temperature, not time, okay. So this is mL T minus 3 K minus 1. Fourth option is there. Then we are having Boltzmann constant. So for Boltzmann constant you can use a relation like PV is equals to NKT. Okay, so PV is energy, okay, divided by T will come, so temperature will come. So mL2 T minus 2 K minus 1, first is coming. Then inductive reactance, that is ohm, okay, inductive reactance, that is ohm. So how will you find the dimensions of resistance? Okay, so any of the formula again, so either you can use power is equals to V square by R, or what we can use, V is equals to IR, you can use R is equals to V by I. What is V? Work done per unit charge. So mL2 T minus 2, work done is energy, okay, divided by charges, ampere into time. Then current as ampere. So this will become mL2 T minus 3 A minus 2, third option. 3, 4, 1 and 3. Sorry, 2, 4, 1 and 3. These options are typed in haste. 2, 4, 1 and 3. Fourth option. Now many of you will be watching this in recorded, I know, because very less students are there in the live. But make sure you watch this before April attempt. A screw gauge, in a screw gauge the zero of the circular scale lies 3 divisions above the horizontal pitch line. When their metallic studs are brought in contact, it means the zero is 3 division above. It means my zero error is negative. Zero error is negative. Negative. 3 divisions above, so zero error will be 3 into the least count. Then using this instrument, thickness of a sheet is measured if pitch reading is 1 mm and circular scale reading is 51, then correct thickness of the sheet is. So when I write the correct thickness, let us take T, that will be equals to main scale reading. How much is that? 1 mm. So main scale reading plus the circular scale reading. Circular scale is showing 51. So 51 into the least count minus zero error. So when you subtract this, it will become plus 3 into least count. So this is 1 mm plus 54 into the least count, sorry, not 54, 55. 55, oh, this is 3 now. I got like 54 into the least count. How much is the least count? 0.01. So 0.01. What it is now? This became 1.54 and this is in mm. 1.54 mm. A option is there. So the most important thing from this was checking whether this zero error is positive or negative. As the zeros are above, the zero error is negative. If the zero will be below, the zero error will be positive. Next, when both jaws of Vernier caliper touch each other, 0 mark of Vernier scale is right to 0 mark of main scale. It means zero error is positive. So here we have our zero error, which is positive. How much? Fourth scale of Vernier scale coincides with a certain mark on the main scale division. It means zero error is 4 into the least count. This we got. Next is, while measuring the length of the cylinder, observer observes 15 divisions on main scale and 5th division of Vernier scale coincides with the main scale division. So how we write? The length measured is equal to main scale reading. How much is that? 15 division of on main scale. So 15 into main scale division plus a 5th division of the Vernier scale coincides with the, so that is 5 into the least count and subtract zero error also, so minus 4 into the least count. Now what it is now? 15 into, how much is main scale division? Least count of the Vernier caliper is given as 0.1 mm. Main scale division is not specifically mentioned. That will be 1 mm for standard we can consider. So 1 mm plus this is 1 into the least count. So that is 0.1 mm. So it is 15 plus 0.1, that is 15.1 mm. 15.1 mm, that is fourth option. Next question. Water drop falls from a tap on the floor 5 meter below. Okay, so this is tap here. Let us take like this. So water falls from this tap and this is the floor and this height is 5 meter. Now, at regular intervals of time, the first drop strikes the floor when 6th drop begins to fall. So here is my first drop. Okay, you can say 1. And here is my 6th drop. It is about to fall. So you can say 2, 3, 4, 5 like this. They are not equally separated. I just do them like that. The height at which the 4th drop will be from ground at the instant when the first drop strikes the ground. So when the first drop strikes the ground, how much is this height? We need this. How much time it took for this first drop to strike the ground? Can we find this? Yes. It dropped from a height of 5 meter. So I can say 5 is equals to half g into t square. So t comes out to be 1 second. Now 1 second took for this drop to fall. All the drops are dropping from this height at equal interval of time. This time, this interval 1, 2, 3, 4, 5. There are 5 intervals. So each will have 1 by 5. 1 by 5 second. So this dropped for a second of 2 by 5 duration. 2 by 5 second. Fourth dropped for a time of 2 by 5 seconds. So how much distance it covered? How much distance it covered? You will say half into g into t square, 2 by 5 square. What it is? 5 into 4 by 25. So this is 5. So 0.8. So it dropped 0.8 from the top. What will be the height from the bottom? 5 minus 0.8. So this is 5 minus 0.8. therefore 4.2 meter. Third option, 4.2 meters. Next, the velocity distance graph is shown in figure. Which graph represent acceleration versus x variation of this system? Now, exactly same question I took in the marathon. When I was doing marathon for JEE Mains, so I took this question. This was exactly the same question. Now, first of all, if these type of questions are there, these are, you can say, not standard graphs. It's not VT graph, it's not AT, it's not XT. Generally, we study those curves. So, this is Vx. So, first of all, what we need to do? Write the equation. Let us take this is V naught and this is x naught. So, write the equation. Y is equals to mx plus c. So, y is along V. So, V is equals to m. The slope is minus V naught by x naught m into x is my variable plus the intercept. Intercept is V naught. So, this is the equation now. I know Vx relation. I need what is the acceleration. So, how to do that? A is equals to V dV by dx. Relate acceleration with V and x. A is equals to V dV by dx. I had Vx relation, I need Ax relation. Therefore, we can use this equation. Now, write it down again. So, V is minus V naught by x naught into x plus V naught. This is my V into dV by dx. If you differentiate it, it will give you minus V naught by x naught. Now, multiply it. So, what it will become? V naught by x naught square into x plus, here it will become minus then, minus V naught square by x naught. Now, this is the Ax curve now. It's a straight line. Yes, it's a straight line. The slope is positive, the intercept is negative. Straight line having slope positive and intercept negative, that is second option. Okay, easy? Yes, there were many easy questions asked. A boy throws a ball into air at 45 degree from the horizontal to land it on a roof of building of height h. Okay, if the ball attains maximum height in 2 seconds and lands on the building after 3 seconds. So, you projected it like this. So, the ball went like this. At 2 seconds, it is at maximum height. So, here t is equals to 2 seconds. At 3 seconds, it lands on the top. This is 3 seconds. What we need? What we need? Then the value of h's. So, this we need. What is this h? This speed is not given to us. This is u. This angle is given to us 45 degree. It reaches the maximum height at t is equals to 2. What is the formula for time at maximum, the time it takes to reach the maximum height? U sin theta by g. So, this is my u sin theta by g. 2 is u sin 45 by g. What is g? You can take 10. So, from here I can say what is my u. Okay, and then I can find at t is equals to 3 from the ground what will be this height. 2 is from here I can say 20 is equals to u by root 2. So, u comes out to be 20 root 2. 20 root 2 is my u, this speed. Okay, so along y-axis this is 20, along x-axis this is also 20. Now, I know the initial velocity along y-axis, I know the acceleration along y-axis, I need what will be the height of the ball from ground at t is equals to 3 seconds. So, just use s is equals to ut plus half g minus, okay, minus half g t square along x-axis, along y-axis, or I should write general form plus half a t square, and this I am talking about along y-axis. Now, if you write this equation along y-axis, this my h will be equal to what is uy, that is 20, what is t, that is 3 minus half into 10 into t square, that is 9. 2 into 5, this is 60 minus 45, that comes out to be 15 meter. fourth option. Okay, is that clear to you? Moving ahead, river crossing question. A river of width 200 meter is flowing from west to east with speed of 18 km per hour. So you can draw a diagram that this is a river and this river is flowing in this direction with a speed of 18 km per hour. A boat moving with speed 36 km per hour in still water is made to travel one round trip, okay, bank to bank. Minimum time taken by the boat for this journey and also the displacement along the river bank is, for the minimum time case, the direction of swimming or direction of boat with respect to water will be perpendicular. So let us take boat starts from here. So boat will move in this direction with respect to water. So this will be my velocity of boat with respect to water. Okay, so this is my velocity of boat with respect to water or the river. My river is moving in this direction. This is velocity of water. The resultant velocity will be somewhat like this. The boat will move like this. Will reach here. Again, it will try to come back to this bank. Swim in direction perpendicular because minimum time, so it will go like this, will reach here. Okay, so first of all, minimum time taken by the boat for this journey. So twice the time it takes for crossing. So T is equals to T is equals to 2 into width of the river divided by this velocity of the boat with respect to water. How much is that? That is 18 km per hour. I can convert this, no, this is 36 km per hour for the boat. I can convert this to meter per second by multiplying this with 5 by 18. 18 into 2, so this is 10 meter per second. And if I convert this to meter per second multiplying with 5 by 18, so this will be 5 meter per second. Width of the river is given as 200. So width of the river divided by this velocity of boat with respect to water. So this is 2 into 200 divided by velocity of boat with respect to water is 10. So this is 40 seconds. My drift, how much will be the drift? Drift is this total distance, that will be the time into the velocity of water, because only water is making that boat move in this direction. There is no component of boat itself in that direction. So how much that distance will be? Velocity of water or the river into the time, this total time. How much it is? This is 5 into this time was 40 seconds, not 4 seconds. This was 40 seconds. Into 40. So this is 200 meter. 40 second and 200 meter. 40 second and 200 meter, that is third option. Standard question. What change NTA made was, he asked for a round trip. Otherwise we studied, for minimum time, how much it takes, how much is the drift. So we generally, in class we solve this question, how much is this drift, how much time it will take to reach on the other bank, like that. That we studied. Now NT made the change, give a complete round trip. Simple thing. Twice of that. Next question. In case of vertical circular motion of a particle by thread of length r, if the tension in the thread is 0 at an angle of 30 degree shown in the figure. So here this tension is 0. This tension is 0, that is given to us. The velocity at the bottom point A of the circular path is, what is this velocity? Let us take this as V naught. How much is this V naught? That we need. Okay. Now tension is 0 here in this case. So what all other forces are there? One force is force due to gravity, mg in this direction. Is there any other force? Is there any other force? No other force is there. So mg is there in this direction, Okay, and we are having a centripetal acceleration because this is moving in circle, so we are having centripetal acceleration in this direction. Let us take this velocity to be v. Here the speed is v. So I'll say the force along the centripetal acceleration will be mg, and this is 30, so this is 60, mg cos 60. So mg cos 60. Tension is there? No, that is 0. Is equals to mass into centripetal acceleration. So v square by the radius r. Mass got cancelled. So I can say v, that comes out to be root of rg cos of 60, that is 1 by 2. That is 1 by 2. So root of rg divided by 2. I got this speed here. I need, what is the speed here at A? So what will I do? Apply conservation of mechanical energy. Got it? So anytime this type of questions are there, first of all, write the force acceleration equation there, find how much is the speed there, okay, and then apply conservation of mechanical energy. Now this is my A, and this is, let us take this point as B, okay. So you can say kinetic at A and potential at A is equals to kinetic at B plus the potential at B. Conservation of mechanical energy. Conservation of mechanical energy. COME. COM generally we write for conservation of momentum. Conservation of mechanical energy means COME. Just a representation. Now just write the equation. Kinetic at A is half mv naught square. Half mv naught square. What is the potential? I am taking this as reference. So I'll say my potential energy is 0 there. Plus 0 is equals to kinetic at B here. How much is the kinetic? Half mv square. So half m into v square. So this will become rg by 2. Half mv square plus the potential energy there. How much is the potential energy? Mg into this total height. How much is this total height? This height we know that is, this is r. So this is r cos 60. And this is r. So r plus r cos 60. R plus r cos 60, that is r into 1 plus 1 by 2. 3r by 2 into mgh, okay? Yeah. M got cancelled. And half also we can cancel. So v square by 2 is equals to half rg by 2. And this is 3 by 2 rg. This half is also getting cancelled. So 3 plus 1 by 2 is 7 by 2 rg. Root of this became our v naught, which is first option. Now what variety from vertical circle, circular motion can somebody ask in mains? In advance, there are so many things. But in mains I am talking about hardly few things. Okay, can ask. First standard thing that we learn in the class is how much is the minimum speed such that it completes the circular. That is root 5 cr. Okay. Now he may, he gave another condition that here the tension is becoming 0. Then just apply force acceleration equation and conservation of mechanical energy. 2 equations, we got the answer. Next question. 2 cars A and B are each of mass 10 to the power 3 kg are moving on parallel tracks separated by distance 10 meter. Okay. 2 parallel tracks are there and they are separated by distance of 10 meter like this. In same direction they are moving with 72 km per hour and 36 km per hour. First of all, convert that to meter per second. Okay, if you convert this to meter per second, again 36 into 5 by 18. Why do these steps again and again? So that you remember them, that this is the way we do conversion and all. Then again if you convert this, so 75 into 5 by 18. So this will become 20 meter per second. So one car is here, it is moving in this direction with speed 20 meter per second. This is car A. Another car B is here, it is moving in this direction with speed 10 meter per second. Then what is the condition? The magnitude of angular momentum of car A with respect to car B. Car A with respect to B. So if you observe car A with respect to B, okay, you make this as a reference. This is velocity of A minus velocity of p, this is 10. So this will have velocity in this direction, how much? 10 meter per second, and this is velocity of a with respect to b. This is velocity of a with respect to b. Now how we write the angular momentum? R cross p, okay, R cross p, or I can say m v r perpendicular, or I can say m v perpendicular into r, anything. So when I write the angular momentum, so that is m into, what is this, v with respect to that is 10, okay, m is mass of a, I am writing, okay, into 10 into the perpendicular distance, that is also 10. What is mass of a? 10 to the power 3. So this became 10 to the power 5. 10 to the power 5. That is option second. Okay. Sir, kindly upload all physics chapter, sir. We are uploading. I think now modern physics will come. Okay. So chapters are coming. A small block of mass m slides down from top of frictionless inclined surface. So from here this block slides down. While the inclined plane is moving towards left with a constant acceleration of a naught, the angle between inclined plane and the ground is given as theta, and its base length is given to us as L. Assuming that initially the small block is at top of the inclined plane, the time it takes to reach the lowest point of the inclined plane is. So from here to here it has to reach with respect to inclined plane, not with respect to ground. If you see with respect to ground, that's a, you can say, different path actually. So with respect to inclined plane, I know it will cover this much distance. Therefore, analyze this complete, you can say, picture in frame of inclined plane. Now I am analyzing this motion of this block with respect to inclined plane. Inclined plane is a accelerating frame, okay, that is non-inertial frame of reference. You need to apply a pseudo force. Pseudo force will be in opposite direction of the acceleration of the frame of reference. How much that force? M into a naught. Is there any other force? Yes, this is mg. Is there any other force? Yes, this is normal. Is there any other force? No. And this will be the acceleration of a relative. This will be the acceleration of this block with respect to inclined plane, because everything is in reference of the inclined plane now. So this mass into a relative is equal to the total force in this direction. How much is that? How much is that? This is mg, so this is mg sine theta and minus of m a naught cos theta. See carefully how I am talking about. So this is mg, this component will be mg sine theta, okay, this is m a naught, that component will be m a naught cos theta. Okay, so m a relative is equals to mg sine theta minus m a naught cos of theta. M got cancelled. This relative acceleration comes out to be g sine theta minus a naught cos of theta. Okay, now I know the acceleration. How much is this distance? This distance I need. This is L, so this distance will be L by cos theta. So the time half into this L by cos of theta. This my distance L by cos of theta. This is my displacement, is equals to half into a relative into t square. So time is equals to root of 2 into the distance, that is L by cos of theta, divided by the relative acceleration. How much is that? G sine theta minus a naught cos of theta. Now you can simplify and check which option is correct. Getting it? Moving ahead. In the given figure, the blocks A, B, C weigh 4 kg, 6 kg, 8 kg respectively. The coefficient of sliding friction between any two blocks is 0.5. The force F to slide the block C with constant speed is, you are moving this block C with constant speed. Constant speed means zero acceleration. So this system will also be moving towards the right with zero acceleration. Now in this question, NT answer was wrong. Okay, NT mentioned 210, so that was also wrong. I don't know, like NTA corrected that or not, that I need to check. But the answer in the provisional answer, the answer key, that was wrong. So now this C block is moving with constant speed. So let me, okay, what it is coming? Anyway, let me draw, or let me simply draw this block C, free body diagram. This is block C. In this direction we are having force F. In this direction we are having tension force T. Is there any other force? Yes, force due to friction on both the surfaces. On this lower surface, friction will be there. Is this friction static or kinetic? Kinetic, because block is moving. This friction is kinetic. How much? Mu into n. How much is the normal reaction on this floor? How much is that? Total mass? How much is that? 6 plus 4, 10, 18. So this normal is 180. Okay, mu n. So 180 into 0.5, that is 90 Newton. This friction we got. On this surface also friction will be there. That friction is static or kinetic? That is also kinetic, because the B block is moving towards the right, the string will pull it. C block is moving towards the left, there is slipping between the two surfaces. That surface, that friction on that surface has to be kinetic. How much? Mu n. How much is the normal reaction on this surface? Or how much is the normal reaction on this block B from C? So you can say that is 6 plus 10, that is 6 plus 4, that is 10. So 10 G, that is 100 Newton. Okay, so this is 100 into 0.5, which is 50. This block is moving with zero acceleration, because moving with constant speed, so acceleration is 0. Now write the equation. Now write the equation for this. So I will say my F has to be equal to total force towards the right, that is T plus 50 plus 90. So T plus 140. This is my F. Now analyze these two blocks, A and B. First of all, the basic thing, between A and B, the friction is kinetic or static? Can you tell me? Between A and B. Between A and B, the friction is static in nature. Why so? This friction here is static in nature. Why so? Because these two blocks, now actually this friction force is 0, but I am telling you this is not kinetic. Why so? Because they are moving with zero acceleration. Zero acceleration, because speed is constant, it means its acceleration is 0 in this direction. If acceleration is 0, is there any external force needed for this block to move with block B? No. So actually here this friction force is 0. And these two blocks will move together. That is the key. Yes, initially when these blocks start, there will be some static friction. But once they are moving, this friction force will be 0, because acceleration of A is 0 in the horizontal direction. Therefore, force on block A has to be 0 in the horizontal direction. Therefore, this friction is 0. Now, these two blocks A and B are moving together toward right. This is A plus B now. They are moving towards right. We are having this tension force T. Is there any other force? Yes, friction force in this direction here. Is that kinetic or static? That is kinetic. How much? 50. Acceleration of this block is 0. A plus B is combinedly having 0 acceleration. So tension comes out to be 50. From here, I can say this tension force comes out to be 50. if this tension is 50, put it here, F comes out to be 50 plus 140, that is 190. Many people solved this question in a wrong way. Okay, in many of the coachings also they provided a wrong solution. They considered this friction to be kinetic between A and B. That is wrong. It's not kinetic. That if you consider this kinetic, then it was coming 210, which was matching with the NT answer, but that was actually wrong. Next question. The flexible chain of mass m hangs between two fixed points at the same level. The inclination of chain with the horizontal at 2 points of support is 30 degree. So how the chain will look like? This chain is hanging somewhat like this. And this chain makes 30 degree with the horizontal at the support. The inclination of the chain with the horizontal is 30 degree. So this is my horizontal. And you can say, if I extend it like this inclination is 30 degree. Here also, if I extend it like this inclination is 30 degree. From symmetricity, if I say this tension here is T, you will say here also this tension has to be T, because from symmetry, same, left and right is same, so left and right forces has to be same. Now if I draw the free body diagram of this complete chain in the downward direction is having force mg, and in the upward direction this is T sin 30, this is T sin 30. So total upward force is 2T sin 30. This is an equilibrium in vertical direction. Yes, no doubt about that. So 2T sin 30 is equals to mg. And now this 2 and this 1 by 2 will get cancelled. So T comes out to be mg. Okay. Sir, when will JEE English batch will start? Yes, JEE English batch, we are going to launch that. Okay, so I think on 28th of Feb, the video will come, the complete details will come to you. We are starting, no doubt about that, so don't worry, everything is coming up. T comes out to be mg. Now, but I need the tension at the middle point. So if you need tension at the middle point, then draw the free body diagram of half of this chain. Half of this chain. Now half of this chain will look like this. Here, let us take this tension is T dash. Here we are having this tension T at an angle 30 degree with the horizontal. In horizontal direction there is equilibrium. Yes. So for this half chain, I'll say T cos 30 is my T dash. T I already got, that is mg. Put it here. So this is mg cos 30. This became my T dash. I need T dash. Oh, this is a typing mistake. It should be like this. Is this clear? Good question. Simple question, equilibrium question. Statement question. Yeah, here also NT did a mistake. I think in the actual paper here there was a negative sign here. Yes, there was a negative sign here in the actual paper. So I am putting that negative back. An object moves from position R1 to position R2 under a conservative field force F. The work done by the force will be minus of this. No. Whether it is conservative or non-conservative force, work done is equals to integration of F dot dr. Therefore, the first statement is actually wrong due to sign. Next thing, any object moving from one location to another location can follow infinite number of paths. Yes, it can follow. Therefore, amount of work done by object changes with the path it follows for conservative force. No. In definition of conservative force, we say that, whose work done is independent of the path followed. So this is also incorrect. Therefore, both statement 1 and 2 are false. Third. Clear? Next question. A small bob A of mass m is attached to a massless rigid rod of length 1 meter. Here, this is massless rigid rod, length is 1 meter. Pivoted at point P and capped at an angle of 60 degree with vertical as shown. At distance of 1 meter below 1 meter below point P. Okay, this 1 meter below point P. This is also 1 meter. An identical bob B is capped at rest on smooth horizontal surface that extend to circular radius r as shown. If bob B just manages to complete the circular path of radius r, what is the velocity required here for B to just manage to complete the circular path? Root 5 gr. You remember that, na? In vertical circle, circular motion, even if a bob is connected with a thread, the velocity that is needed is root 5 gr. If you can say particle is moving in a circle, there also the velocity minimum needed at the lowest point is root 5 gr. If in case of a rod, then the velocity is root 4 gl. So here we need, after the collision, its velocity should be equal to root of 5 gr. That we need. Okay, then the value of r is. So after collision, when they will collide head on. Yes, they will collide head on. If they collide head on, then the velocity of B will be, they are colliding head on elastically. When two same masses collides elastically head on, their velocities interchange. Their velocities interchange. So just before collision, if I show you the picture, just before collision, okay, this is B at rest, this is A, just going to hit it. Just this is A, it will be having some velocity. Okay, this is my A. How much velocity it will have? I can apply conservation of mechanical energy. Okay, how much height is this? This is 1 cos 60, so this is 1 by 2. Okay, so half mgh, you can say mg into h is 1 by 2 is equals to half mv square. Simple thing. So velocity comes out to be root of g, that is root of 10. Root of 10. mg into h, this is decrease in potential energy, is equals to increase in kinetic energy of A, so half mv square. So from there my v comes out to be root 10. So this is moving with root 10 meter per second. This is elastic collision. After collision, what will happen? Their velocities will interchange, will exchange. Okay, so after collision, B was having velocity 0, okay, B was at rest. So after collision, A will come at rest and B will move with velocity of root of 10 meter per second. And A will come at rest. Here this was at rest, B was at rest. This is very important point to remember. Please keep this thing in mind. If two particles having same mass collides elastically head on, their velocities will interchange. Yes, velocity exchange. Naman is saying mechanical conservation and Ig equation of energy conservation. Yes, 23 S1 shift 1. Okay, great. So we got this. Now this has to be equal to root of 5 gr because this is what is needed, okay, to complete the vertical circular motion. So this is equals to my root of 5 g into r. So this root 10 is equals to root of 50 into r. R comes out to be 1 by root 5. 1 by root 5. None of the options. I think it should be first option. There is some typing mistake in this also. Let us see the actual question, what it was. What was there in the actual question? Just checking. It is, I think it is 1 by, what I missed, root of 5 gr. This is root of 10. So this is r comes out to be 1 by root 5. There is something that is missing. Okay, Radius are up to. So what would be more better to do 20? Okay, I'll come to the questions. Just a minute. I'm just checking if I missed something here. This was 10 here. Velocity half mv square. That comes out to be root of 10. Yes. So this root of 10 will be the velocity of B after the collision. Yes. And this has to be equal to root of 5 gr. Oh, sorry. Root r is equals to 1 by root 5. Therefore, r is equals to 1 by 5. Not root 5, 1 by 5. Yeah. Yes, what was asked? Sir, what would be more better, doing 2026 Jan shift paper as mock or do them in time bound manner and give mock test for any test series available? Kindly tell, sir. You can do both the things, okay, because there are 10 papers, you can give them as mock also, and then you can improve from there. Okay, then you need to improve also. Okay, you write which questions you are having difficulty with, from which topics you are having difficulty with, cover those subtopics again, and you know, then improvement has to be there. Okay, so for them, then again you may give some other mocks if you need. Okay, yeah. Sir, wave optics, please, one shot. Yes, next one shot will be of modern physics, and then after ray optics will come. R is coming 1 by 5 only. Yes, Naman. Yes, it was 1 by 5 because it was root R actually. I mentioned R is equals to 1 by root 5. That was, if it takes square both sides, then R will be 1 by 5. So both things you can do, or second thing also you can do, that you solve them without any time bound. Okay, solve all the question nicely, because I want you to analyze that in a better way. Okay, so don't check yourself if you want. Okay, solve all the 250 questions nicely. Okay, giving time to it if you have time. Okay, without any bound, and then analyze the things from there, and with time bound you give the marks. That also you can do. Next question. A flywheel having mass 3 kg and radius 1 meter is free to rotate about horizontal axis. This is a flywheel. It is free to rotate about this axis. The string having negligible mass is wound around the wheel, and the loose end of the string is connected to 3 kg mass. Okay. This is 3 kg mass. The mass is kept at rest initially and released. Okay, kinetic energy of the wheel when the mass descends by 3 meter. So this was the initial condition. Now the mass descends. Okay, this 3 kg mass descends down, and this is, how much is this distance? 3 meter. Now let us take here, this velocity becomes v. If this velocity becomes v, it will rotate with omega, and we know omega will be my v by r, radius. How much is the decrease in the potential energy? mgh. That will be equal to increase in the kinetic energy, total kinetic energy of block plus this wheel. Yes, same simple thing, conservation of mechanical energy. Okay, so decrease in the kinetic energy, that is mgh, is equals to increase in the kinetic energy. So I can say half into m into v square plus kinetic energy of this, half I omega square. So half I omega square. Sir, please first do wave optics. First, it will be helpful for boards also. I think modern physics will be coming tomorrow. I have already recorded that modern physics. I'll be trying for wave optics. Okay, I'll be trying for wave optics also, but I'm not sure because the time is very less. At least so modern physics, complete all the 3 chapters of modern physics that are there. So that will be coming tomorrow. Now put the values. M is, anyways, let me put it first. What is I? So half into I. This is a flywheel. If it is not mentioned anything, it means this is a shape of disc. So here the moment of inertia about this axis is mr square. So when you write I as, sorry, mr square by 2 for disc, mr square by 2. So r square into omega square will become v square. So this will become half into m by 2 into v square. This is what it will become. Now solving, because all of All the two are having mass 3 kg. Yes, yes. This is also 3 kg, this is also 3 kg. Therefore, I am cancelling the m part. So, GH comes out to be 1 by 2 plus 1 by 4 is 3 by 4 V square. So, V comes out to be root of 4 GH by 3. And I need this kinetic energy is mentioned, okay. So, this kinetic energy, this is what we need. So, this kinetic energy is half I omega square, and again writing that as half I as mr square by 2 omega square. Now, this part V square is our 4gh by 3. So, this will become 1 by 4 into mass is 3 into 4gh by 3. 4g into h by 3. 30 joules. 30 joules. Okay. Next question. Two circular discs of radius each 10 centimeter are joined at centers by a rod of length 30 centimeter and mass 600 gram. And also, as Naman was asking sir to analyze all the papers and then giving the marks. This discussion, Naman, what we are doing to help the students. You know that already students are, you know, now board pressure and all the things are going on. So, many less students are also there in this live due to that reason. But you should watch this recorded. If you don't have that much time, that you solve all the 250 questions there and then you analyze the thing. If you don't have that much time, okay, see this, watch this video. Here from the 250 questions, I have selected questions, okay, which are important. Now do at least these questions very nicely. Okay, so that you're in less time. Now time is very less, board is also there, and then when the boards will go, you know, April attempt will come then. So there is hardly any time for the students to go through those 50 questions, 250 questions also, and then give the mocks also, and you have to do that in all 3 subjects. Therefore, these live discussions, yesterday was for maths, today we are having for physics, and then, you know, chemistry will also come. So these live discussions are there to actually help you to cover all the questions of the April attempt. Yes. 30 centimeter mass 600 gram as shown in the figure. If the mass of each disc is 600 gram, each is having 600 gram, and applied torque between 2 discs is this much is the torque that we are applying. The angular acceleration of the disc about the given axis AB is. Now about this axis we need how much is alpha, angular acceleration. So what we'll do, total moment of inertia we'll find, and I'll write tau is equals to I alpha. So simply alpha is equals to tau by I. So only thing is we need to find I. For discs also, and for this rod is also having mass. Yes, rod is also having mass for this rod also. Due to this disc, for this disc, about this axis, what is the moment of inertia? This is along the diameter, mr square by 4. So this is mr square by 4. I need about this axis, so apply parallel axis theorem. So this will become mr square by 4 plus m into, how much is distance? 10, that is equal to r only, so mr square. Similarly, about this axis, for this disc it is mr square by 4. Now apply parallel axis theorem, I need about this axis, so it will become mr square by 4 plus m into the distance square. How much is this? 20 centimeter, that is twice of r. So this will become 2r square, so that is 4r square. Plus the moment of inertia of this rod. Now about the center, if I write first, where is the center? Center will be somewhat here. Rod is having a length of 3r. So ml square by 12, m into L is 3r, ml square by 12. All the 3 masses are equal, therefore I am just writing m there. So ml square by 12, that is about this axis, but I need about this axis, I need. So about this axis if I write, plus md square. So plus m into, how much is this distance? This is 5 centimeter. Yes, that is r by 2. Yes, m r by 2 square, so mr square by 4. Now if you need the total moment of inertia, this plus this plus this, I is equals to this. How much it is? mr square by 4 plus mr square, 5 by 4 mr square plus this. How much it is? 4 plus 1 by 4, that is 17 by 4. Am I right? Yes, 16 plus 1, 17. And then we are having this 3. If I take out, this will become 3 square. 1, 3 will get cancelled. 3 by 4 plus 1 by 4 is 1. So plus mr square. What it is now? 17 plus 4. 17 plus 5 is 22 plus 1 plus 2 plus 4, that is 26 by 4 mr square. Let me check again. 22 plus 4, that is 26. Yes, this is 13 by 2 mr square. Now I got. Put this I in this equation, so I'll write my alpha. This is how much is the torque? Torque is 45 into 10 to the power 5 dyne centimeter. Convert that to SI unit. 43. This is dyne centimeter, so 10 to the power 5 is there. Dyne, if I convert that to Newton, so 10 to the power minus 5 will come. Centimeter, if I convert that to Newton, 10 to the power minus 2 will come. Now things seems fine. Divided by 13 by 2. 2 will go in the numerator. M is 600 grams, so 0.6 into r square. R is 10 centimeter, 10 to the power minus 1. 10 to the power minus 1 square is 10 to the power minus 2. This 10 to the power minus 2, this 10 to the power minus 5, they are getting cancelled. And what else? Nothing else. Let us see what we are getting after calculation. Let us do. This is 43 into 2, 43 into 2 divided by 13 and 0.6, 11.02. This comes out to be 11.02. I'll say fourth is the correct option. Can you provide blank PDF please? Blank PDF of this part you are asking? Please mention. We can provide that also. Sir, please. Okay. I think you are talking about this blank PDF. Yeah. Yes. We can provide both with blank also and with solution also. A uniform bar of length 12 centimeter and mass 20 meter. Sorry, 20 m, not meter. They should be together. This is 20 m. Lies on a smooth horizontal table. 2 point masses m and 2m are moving in opposite directions like this with the same speed of v and in the same plane as that of the bar as shown in figure. These masses strike the bar simultaneously and get stuck to the bar. Okay, after the collision, the entire system rotating with angular frequency omega, the ratio of v and omega is. Now, for this system, for this total system I am talking about, this 2m, this m and this rod. Where is the center of mass? For rod, the center of mass is at center. This is 2m at 2 centimeter, this is m at 4 centimeter. Therefore, resultantly, here is my center of mass. So, about center of mass, my total initial momentum I am doing equal to my total final angular momentum. So, what is the total initial initial angular? Because on this system, is there any torque external? No, that is not there. So, therefore, we can conserve the angular momentum. Now, about center of mass, how much is initial angular momentum? This, that is 2m into this is coming with speed v into this 2 centimeter distance, and same sense, because this is r cross p out of the plane, and here also r cross p out of the plane. Both the angular momentum are actually in the same direction, therefore they will add. So for this I write 2m into v, the distance is 2 centimeter. I am writing that in centimeter. We will convert that. This is due to 1 into 2. This is the total initial angular momentum is equals to my final angular momentum. Finally, this whole system will both the masses will stick here, and you know the whole system is rotating with angular acceleration omega, sorry, velocity omega. So due to this rod, if I write the angular, I'm just writing I omega, okay. So due to this rod, if I write the moment of inertia, that will be ml square by 12, m is 20 m, so 20 m, m into L square, L is 12 centimeter divided by 12, this is due to rod. Now due to this particle, 2m into 2 square, and that will have m into 4 square. So 2m into 2 square, that will become 4, okay, so 2 centimeter square plus that m into 4 square. This becomes my total I into omega. This is my 2 into 2 into 2, that is 8 mv, and there is 1 centimeter. Here we are having centimeter square. Here we are having centimeter square, here we are having 1 centimeter. So that centimeter unit will get cancelled with 1 of the centimeter here, and 1 centimeter will take out there. Getting it? Yes. So here into centimeter is also there, you can say like this. M will also get cancelled, and this 12 you can cancel, 112 you can cancel, centimeter square will be there, and let me write it again. So 8 V and 1 centimeter unit is there, and here we are having 12 into 20 is 240, 1 centimeter unit is there, plus 2 into 2 4, sorry 2 square, 4 into 2 that is 8, plus this is 4 square, that is 16 centimeter unit is there, okay, into omega. 8 into 1 into 2 into 3, 0. So this is 33 centimeter, and this is V by omega. So V by omega is coming out to be 33. Yes sir, only question, okay, okay. Where I get the PDF, sir? That PDF we will provide on our WhatsApp channel, okay. So both we will load the blank also and with solution also, both you will get there. I think, I hope you are there on our WhatsApp channel. So if you are not there, in all the description you can say of the videos, you will get the link for WhatsApp channel also, you can join. So this is coming out to be 33 centimeter. Now it's not mentioned that V by omega ratio you have to mention in centimeter. We expect NTA to give the complete details to the students, because if something is default, that is taken as SI. If something is default, that is taken as SI. So generally student will think like V by omega should be in SI then, meters, 0.33, but they want us to mention in centimeter. 64 raindrops of radius 1 mm each falling down with terminal velocity of 10 centimeter per second coalesce to form a bigger drop. The terminal velocity of the bigger drop is, all other parameters are same, the radius is changing, density is same, coefficient of viscosity is same, everything else is same, only the radius is changing. How the terminal velocity is related with radius? We know the formula, V terminal is equals to 2 by 9 r square g by eta delta rho. We know this formula. How we got this formula? We got my 6 by r eta v is equals to the difference between the two forces mg and the force due to buoyancy, that is 4 by 3 pi r cube into delta rho into g. From there we got this equation. So we know that V terminal is basically proportional to r square. V terminal is proportional to, how my R is changing, we need 64 drops, okay. So conservation of volume I am doing, so 64 into the volume of each drop, 4 by 3 pi into 1 mm initial radius is equals to the volume of the final drop, 4 by 3 pi into r cube, 4 by 3 pi, 4 by 3 pi. From there I got my R comes out to be, 64 is 4 cube, so 4 mm. So radius is getting 4 times, terminal speed should get 16 times. So V terminal dash should be equals to 16 times of V terminal. What was the initial V terminal? 10 centimeter per second. Now it should become 160 centimeter per second. Clear? A brass wire of length 2 meter and radius 1 mm at 27 degrees Celsius is held taut between two rigid supports. Initially, it was cooled at temperature minus 43 degrees Celsius, creating a tension T in the wire. Now, you are holding this brass wire between two rigid support. If you decrease the temperature, what will happen? Contraction will happen. Increased temperature means expansion happens. Decreased temperature means the rod will try to compress back. If the rod will try to compress back, but you are holding that rod between the two rigid support, what will happen? Some tension will be generated in the rod due to that. The temperature to which the wire has to be cooled to increase the tension to 1.4 T. Okay. Let me take, this is our rod, and you are holding it between rigid support. Initial natural length, no tension. Now you are decreasing the temperature. You are decreasing the temperature by how much? Minus delta T, let us take. How much length will change? Length will decrease. How much will be delta L? L alpha delta T. How much strain will come? Alpha delta T. How much force will come? We know stress by strain is equals to Young's modulus. Okay, Young's modulus is my stress, force by area divided by strain, delta L by L. So basically my force is coming out to be proportional to delta L by L. So proportional to delta T. Force is proportional to delta T. Initial condition, temperature goes from 27 to 43. My delta T1 is equals to the difference between the two. How much is that? You can say this is 27 plus 3, 0, okay, 1, okay, 4 plus 2, 70. Yeah, perfect. Yeah, 70. So 70. This delta T1 was 70. Finally, it is going from some final temperature and the tension became 1.4. So I will say my T is proportional to 70 and my final 1.4 T is proportional to, let us take some another temperature. Initial was 27, so 27 minus my T final temperature. Take the ratio, solve for T final. Clear? Good to go? You can do the calculations. I am not doing the final calculation. A wire A and B made of different materials of length 6 centimeter and this 5.4 centimeter respectively in area of cross section. This is 10 to the power 5 meter square and 4.5 in 10 to the power minus 5. Okay, here also it should be minus 5 then I think. Are stressed by same magnitude under a given load. The ratio of the Young's modulus of A to that of B is x is to 3. We need what is the value of x. You applied the same load and they are stressed by the same, you can say, magnitude, means the expansion that came is equal. Expansion that came is equal. How we write delta L? FL by AY. You remember this? If you don't remember this, so just write Y is equals to stress by strain. From there, delta L comes out to be FL by AY. Remember it like this. Now delta L is equal in both case. Okay, so my F and force is also equal. Force is equal, area of cross section is different, lengths are different, and Young's modulus are different. Okay, so delta L1 is basically equal to delta L2. So I say F L by AY for 1 is equals to F L by AY for 2. Both forces are equal. L1 and L2 are given as 6 and 5.4. So 6 here, 5.4 here, divided by. Areas are given as 3 and 4.5. Just write 3 and 4.5 because 10 to the power, that part will anyways get cancelled. 4.5, and here this is my Y1 and this is my Y2. Seems fine? Yes. 9 into 0.9 into 6, 0.9 into 5. This 6 is getting cancelled. So y1 by y2 comes out to be 3 by 5 of A to that of B. So y1 by y2 is coming 5 by 3. Yeah, 5 by 3, x comes out to be 5. Clear? Good. Venturimeter, simple question. Water flows through horizontal tube on as shown in figure. The difference in heights between the water columns in the vertical tube is 5 cm. This. The area of cross section at A and B are given as 6 and 3. Okay, this is A actually here. Here this area is 6 cm square. Here this area is 3 cm square. The rate of flow will be this and this rate of flow is centimeter cube per second, means both. This is A into V. A1 V1 is equals to A2 V2. Doesn't matter whether you find here the rate of flow or here, that will be equal. Now let us take here the speed is V1, here it is V2. A1 V1 is equals to A2 V2. A1 is twice of A2. So V1 is V2 by 2. Now write the equation, Bernoulli's theorem between 2 points, this and this. Bernoulli theorem means V1 plus half rho, that is rho only, rho V1 square plus rho G Y1 is equals to P2 plus half rho V2 square plus rho G Y2. These 2 points are on the same level, thus Y1 and Y2 are same. Difference between P1 and P2, rho G H1, rho G H2, so rho G delta H. P1 is greater, so P1 minus P2 comes out to be half rho V2 square minus V1 square. V1 is or I can say V2 is twice of V1. So this is half rho twice of V1. So 4 V1 square minus V1 square, and this is P1 minus P2, that is rho G delta H. Okay, this delta H 5 centimeter. Let me write this as H or delta H. Let me write this H as H. So this will become rho G H. This rho is getting cancelled. From here V1 square comes out to be, this is 2GH, 2 into GH and divided by 3. So V1 comes out to be root of 2GH by 3. This is root of 2 into what is G? G is 10. What is H? H is 5 centimeters. So 5 by 100 into 3. So this and this is getting cancelled. This comes out to be 1 by root 3. I need what I need, rate of flow A into V. So A1 V1, that is my Q actually. A1 V1, that is I need. What is A1? A1 is 6 centimeter square. I need in centimeter cube per second. So 6 into, this is 1 by root 3. This is in meter per second. I need to convert that to centimeter per second. So multiply that with 100. What it will become? 2 root 3, 100. So 200 root 3. 200 root 3. Fourth option. Okay. Please see. If you have anything to ask, you can ask. Next question. A cubical block of density 600 kg per meter cube floats in a liquid of density this much. If the height of the block is this, then the height of the submerged part is, very simple question from Archimedes principle. The block is something like this. Downward force mg, upward force force due to buoyancy, that is V in rho liquid, okay, rho, this liquid is water or what? No, rho liquid into G, okay, because this is in equilibrium, I can say V in rho liquid into G is equals to my mg. What is V in? This volume, area of cross section into this. This is what I need. Then the height of the submerged. Yes, let us take this height as h, small h. Okay, so V in I can write as area of cross section into this h. This becomes V in into rho liquid into G is equals to mass, total volume. Total volume is area into the side, area into the side. Height of the block is 8 centimeter. So this is my h actually, capital H into G. Anyways, this G is getting cancelled, this A is getting cancelled. So I got my the small h is equals to this is volume into the density of the block also. So rho block into H divided by rho liquid. Simple thing. What is rho block? 600. What is rho liquid? 900. So 600 by 900 and H was 8 centimeter. Multiply that with 8, answer will be in centimeter. So this is 300 into 2, 300 into 3, 16 by 3. 16 by 3. 16 by 3 is 5.33. Fourth option. Is this clear? Good. Next, thermodynamics. A thermodynamic system is taken through a cyclic process ABC. I shown the total work done by the system in this cycle, you know, very straightforward question. This is a PV curve, this is pressure, this is volume, and this is clockwise, therefore the area work done is positive, okay. Just take the area of this. So work done is equals to area of this curve, that is 1 by 2 into the base is 5 minus 2 is 3 into the height is 300 minus 100, that is 200. This is Pascal SI, this is meter cube, that is also SI. So this becomes 300 joules. So the answer is 300. Next, the internal energy, just a minute, I think there is some cursor that is coming, just a second. Okay, I'm back. Raj Manohar is saying, sir, Akash. Yes, I was there in Akash before. You might have seen me. The internal energy of monatomic gas is 3 nRT. Okay. How we write the internal energy? U is equals to NCVT, isn't it? So my N CV into T is given as 3N RT. What does it mean? CV is equals to 3R. One mole of helium is capped in, they want, you know, monatomic gas internal energy is given like this. Generally for monatomic, if you talk about, I will say NCV delta T, CV is equals to 3R by 2. But they are giving us a condition where the internal energy is given like this. If that is given, take it like this. 1 mole of helium is capped in a cylinder having internal cross section of this and fitted with light movable frictionless piston. This is light movable frictionless piston. The gas is heated slowly by supplying 126 joule of heat. If the temperature rises by 4 degrees Celsius, then the piston will move up by. Okay, you gave some heat to the system. Here the temperature increases and delta T is 4 degrees Celsius. How much heat you gave? You supplied Q, that is given as 126 joule. Okay, in this condition, if I ask you how much is the pressure inside the gas, okay, how much is the pressure of the gas? Now this piston is my massless piston, that is given, okay, and this piston is in equilibrium, so outside pressure is equals to inside pressure. This is piston is massless. So actually this here, the expansion that is happening, that is isobaric process. Pressure is constant of the gas. How much is that? Pressure of atmosphere. So this is actually an isobaric process. Isobaric process it is. I need, how much is this delta X? So for isobaric process I can say Q is equals to N Cp delta T. Cp is equals to Cv plus R. So if Cv is 3R, Cp is equals to 4R. And Q is 126, yes, so 126 is equals to N, how many moles? 1 mole. So 1 into Cp is 4R. Okay, anyways, I don't need delta T, by the way. No, I don't need that. I don't need that. I need how much is the work done. So Q is equals to my change in the internal energy plus the work done. Like this we can write. This is 126, so 126 is equals to work done, you can write as P delta V. How much is the pressure? P naught, atmosphere pressure, P delta V, plus delta U. Delta U can write as NCV delta T. Okay, so 3 N R delta T. So this is 3 into N is 1 into R into delta T is 4. I put it as NCV delta T. Simple. From there I will get my P delta V, area of cross section we know, and from there I will get how much is my delta X. Delta V I will write as A delta X. Like this I will write. 4 into 3, 12. So 126 minus 12R. Now put the values. So this is 126 minus 12 into R is 8.31. 8.31 divided by P naught. P naught is 10 to the power 5. 10 to the power 5 into the area of cross section is 17 centimeter. So 17 into 10 to the power minus 4. This will come out to be my delta X. Okay, now from here you can do just these calculations and you will get the value of delta X. Next question. An air bubble of volume 2.9 centimeter cube rises from bottom of the swimming pool of 5 meter deep. Okay, at the bottom of the pool the water temperature is 17 degrees Celsius. The volume of the bubble when it reaches the surface where the temperature is 27 degrees Celsius. Okay, so let us take, initially the bubble is here and now this bubble is rising. Okay, and then the bubble came here. Here the pressure is my P1, volume is V1, my temperature is T1. Here the pressure is P2, volume is V2, temperature is T2. What is P2? P2 is atmospheric pressure. Okay, so this is my P naught. So P2, let me write here P2, because this is on the surface. Okay, therefore P2 is P naught. What is P1? P1 is equal, so this is at a depth 5 meter. So P1 is equal to P naught plus rho GH. H is 5. Like this. How much is P naught? 10 to the power 5. So 10 to the power 5 plus rho is 10 to the power 3. This is water. G is 10 and then 0.5. So this is, and then it is 5. So 5 into 10 to the power 4, which I can write as 0.5 into 10 to the power 5. So this comes out to be 1.5 into 10 to the power 5. And thus P naught is 10 to the power 5. What is T1? At the bottom of the pool water temperature is 17 degrees Celsius. So convert that to SI, add 273. How much it will be? 290. Finally this is 27. So this is 300 on the surface. So at the bottom my T1 was 290 and Kelvin. Okay, and here my T2 is 300 Kelvin. Same amount of gas is there in the bubble. P1 V1 by T1 is equal to P2 V2 by T2, because N1 is equal to N2. Simple thing. So P1 V1 by T1 is equals to P2 V2 by T2. What is P1? Here, okay, 1.5 into 10 to the power 5. What is V1? V1 is given to us, sorry, V1 was 2.9 centimeter cube. divided by what is T1? T1 is 290. Here P2 is 10 to the power 5. V2 we need to find, divided by T2 is 300. Now this 10 to the power 5 is getting cancelled, this 10 is getting cancelled, and V2 will come out to be 1.5 into 2.9 divided by 29 into 30, and this in centimeter cube, 2.9 into 10, this 10 is getting cancelled, so this comes out to be 4.5 centimeter cube. 4.5 centimeter cube, fourth. Sometimes NTA makes the calculations very straightforward like this question. Sometimes the calculations are there, you need to, generally I used to take help of calculator. Certainly you cannot take help of calculator in the exam, but if calculator is not there, then you need to spend more time. But here the calculations were easy. Now question on heat transfer. Rod X and Y of equal dimensions but of different materials are joined as shown in figure. Temperature of end points A and F are maintained at 100 degrees Celsius and 40 degrees Celsius respectively. Given the thermal conductivity of rod X is 3 times that of rod Y, the temperature of the junction points B and E are close to. Okay, how much? Draw a equivalent electrical circuit and analyze it accordingly. How? I know thermal resistance we write as L by Ka. Thermal resistance is given as L by Ka. Now here there are two materials, X and Y, dimensions are same, okay, everything is same, only conductivity is different, and we know conductivity of rod X is 3 times that of the rod Y. If I take resistance of rod Y as R, what will be the resistance of X? R by 3. Inversely proportional to K, na? Here K is 3 times, so that resistance is R by 3. So this resistance is R by 3, this is R, this is R, this is R by 3, this is R by 3, and this is R. Now solve further. These two R and R are in series, so this is 2R. These are in series, R by 3 and R by 3, that is 2R by 3. Now this 2R and 2R by 3 are in parallel. So find the equivalent, you can say resistance. How we write? R1 R2 divided by R1 plus R2. So and then again draw the circuit. Simple thing. So first is R by 3, then this parallel combination, and then R. Here the temperature is 100 degrees Celsius, here this is 40 degrees Celsius. What is this parallel combination? So these parallel combination will be 2R into 2R by 3 divided by 2R plus 2R by 3, that will become 3 into 2 6, that is 8R by 3. This by 3 is getting cancelled, this R is getting cancelled, this will become R by 2. Now this is my R by 2. So first of all write how much is the thermal current. So if I write this thermal current I, that will be total potential difference. Here we write temperature difference as my potential difference, divided by total resistance R by 2 plus R by 3 plus R, that is 5R by 6 plus R, that is 11R by 6. How much it is? This is 60 into 6. 60 into 6 is 360. R divided 360 by 11R. This is my thermal current. How will I write this temperature? This V0 minus IR, okay, and then how I write V0 minus this I into this total R, like that I will say, okay. So if I write the temperature of this junction, I'll say that will be my V0. V0 is here 100 In direction of thermal current, temperature will drop minus IR. So minus I is this 360 by 11R into this R by 3. This was junction B. Okay, this is my TB, temperature at B. And similarly, if I write this junction temperature, this is E. Okay, similarly, if I write temperature at E, that is this V0, that is 100 degrees Celsius, minus IR, I is 360 by 11R, into the resistance is R by 3 plus R by 2, that is 5R by 6. Now do the calculations. One doubt, yes, please ask. Please ask if you want to ask anything. Keshav, please mention. Sir Akash, what do you want to ask? Please mention. Okay, now you do the calculations and you will find what is TB and TA. I'm just skipping the calculation part. Next question. The RMS speed of oxygen molecule is this, is equal to that of the hydrogen molecule at what temperature? How we write the formula for RMS speed? T is equals to root of 3 RT, sorry, VRMS, 3 RT divided by M. This is how we write. Oxygen molecules at this temperature is equal to for hydrogen molecule at this temperature. So, I will say that my T1 by M1 has to be equal to T2 by M2. Sorry. If the two speeds has to be equal, T1 by M1 has to be equal to T2 by M2. What is T1? 47 degrees Celsius. Convert that to SI. So, add 273. How much it will become? This will become 320. Okay. So, 320 divided by M1. What is this is RMS speed of oxygen molecule. So, M1 we know that is 32 grams is equals to T2. We need to find that divided by what is M2? M2 is 2 for hydrogen gas. So, this is 16 into 20. So, T2 comes out to be 20 Kelvin. 20 Kelvin means minus 253 degrees Celsius. Yes. Clear? Many of you would be watching this in recorded form. So, when you saw this, if you have any doubt, you can mention in the comments. I will come back and will respond in the comments. A cylindrical block of mass m, area of cross section A, is floating in a liquid of density rho with its axis vertical. When depressed a little and released, the block starts oscillating. It means oscillation is happening here. The time period of oscillation is. The block is like this, floating like this. Let me draw it properly. This is a cylindrical block. It is floating like this. Now, I am putting it down a bit. Okay. Let us take, pushed it a bit down. How much? By additional amount of X. Let us take this much volume additionally went inside. This much volume additionally went inside, due to which a restoring force will come. How much that restoring force is, that I write as MA, A I will write as omega square X. From there I will get my omega and then we can write the time period. Simple thing. So, if I write my F restoring, okay, that will be my, certainly restoring force is in opposite direction of X. So, my negative sign is there, but do not consider the negative sign, both side it will get cancelled. So, M into A, this is how I will write that. So, restoring force is volume of this, that is X, into area of cross section, into the density of the liquid, into G. This much is the volume of the liquid displaced into density into G. This much becomes the weight of the liquid displaced, that is equal to my buoyant force. Additionally is equals to M into A. How will I write my m I'll just write as m because that is given here m. So m into acceleration we'll write as omega square into the displacement, that is x. So this x is getting cancelled, and from here I can say this omega come out to be a rho l g by m and root of this. Density of the liquid is given as rho only, so take that as a rho. So omega is this, then I'll say, if I say the time period, so time period is 2 pi by omega, so 2 pi root of m by a rho g. Yes, is this clear? Great. Next, consider two boxes containing ideal gases A and B such that their temperature, pressure and number density are same. Temperature is same, pressure is same, and number density means number of molecules per unit volume, that is also same. We know PV is equals to nRT, so I can write PV is equals to N as number of molecules divided by Avogadro number into RT. And this will become P is equals to N by V, this is my number density, into RT by Na. P is same, temperature is same, then Na has to be same, this number density has to be same, Na is Avogadro number, that is constant anyways, this N by V has to be constant, that is given same. So even if he would not have mentioned this separately, I will be considering that as same. Next thing, the molecular size of A is half that of B and mass of molecule A is 4 times as that of B. If the collision frequency of the gas is this, the collision frequency of gas A is, how we relate the collision frequency, by the way? We know that collision frequency is equals to, frequency is 1 by time period is equals to distance divided by speed. So I will say speed divided by my distance lambda, mean free path. Lambda is 1 by root 2 pi d square n. So this will become speed divided by 1 by root 2 pi d square is n, so it will go in the numerator, v into root 2 pi d square n. Now, what all things are same? Root 2 pi and n. Root 2 pi are constant, n is number density, these are same. Speed will be same or not? Temperature is same. Speed we write, certainly here we know that speed is proportional to root t by m. Okay, speed is proportional to root of t by m. Temperature is same, but 1 by m factor will come. So from here, if I say my frequency, that will be proportional to n divided by root of m, like this. Now if I say f1, not n, sorry, d square, n is same for both, d square by root of m. Now if I say f1 or a and b, or yeah, a and b is there. So if I say fa by fb is, this is proportional to density, sorry, proportional to diameter, not density, d is my diameter. How the diameters are related? The molecular size of A is half that of B, means diameter of A is half that of B. So 1 by 2 factor will come here and that square will become 1 by 4. Next, the molecular mass of A is 4 times. So here a factor of 4 will come. If you take the root of that, that will become 1 by 2. So this is 1 by 8. Frequency of A will be 1 by 8 into frequency of B. What is frequency of B? 32 into 10 to the power 18. So this is 4 into 10 to the power 18. Yeah, there was a mistake. By NTA here the options were given with bars 10 to the power 8, which was wrong. So this question was also having wrong options. Good. Next question. As shown in the figure, a spring is kept in a stressed position with some extension by holding the masses 1 kg and 0.2 kg, okay, with separation more than spring natural length, and are released. Assuming the horizontal surface to be frictionless, the angular frequency is. For this type of oscillation, you know the formula, the time period is equals to 2 pi root of mu by k. Instead of m, we write mu there. What is mu? m1 m2 divided by m1 plus m2. Okay. Now, this is a standard formula for these two blocks oscillating like this. I'll do the derivations in the SHM one shot, you will see there. So, m1 m2 divided by m1 plus m2, that is 1 into 0.2 divided by 1.2. 1 into 0.2 divided by 1.2. So, this is 1 by 6. Mu comes out to be 1 by 6. So, the time period comes out to be 2 pi. What is asked here, by the way? The angular frequency, that is omega. Omega is root of k by m. K by mu. K by mu. What is k? K is 150 and mu is 1 by 6, so into 6. Root of 900 is 30. 30 radian per second. Clear? SHM simple question. Simple, I'll say fundamental question. A simple pendulum of string length 30 centimeter performs 20 oscillations in 10 seconds. The length of the string required for the pendulum to perform 40 oscillation in same time. Initially 20 oscillation, now you need 40 oscillation, duration is same. It means time period is getting half. Time period is getting half. My t dash is becoming half of the initial time. How the time period is related? Time period is related as t is equals to 2 pi root of L by G. If time period is getting half, it means my length should get 1 by 4. Okay. So, my length L dash should become L by 4. Then only the time period will get half. So, what was the initial length? 30 centimeter. So, now the length will be 30 by 4. How much will be? 7.5. 15 by 2. So, 7.5. 7.5 centimeter. That is second option. Clear? Okay. Next. In an open organ pipe, mu3, mu6 are third and sixth harmonic frequencies respectively. The difference between the two is given as 2200. The length of the pipe is. How we write the frequency of nth harmon? Fn. Nv by 2L. This is open organ pipe. So, if I write F6 minus F3, that will be 6 minus 3. So, 3 V by 2L. And this 3 V by 2L is given as 2200. What is V? 330. So, 3 into 330 divided by 2L is equals to 2200. And 11 into 3, 11 into 20. And what else? L comes out to be 9 divided by 2 into 20. Means 9 by 40. We need in mm. So, this is in meter. So, if I convert to mm, so this I can write as 9 by 40 into 1000. So, this 4 into what it is? 25. 25 into 9, 225. 225, that is second option. Next question. What's the time? About to, it's 7:48. Okay. Two loud speakers L1 and L2 are placed with separation of 10 meter as shown. Both speakers are fed with an audio input signal of same frequency with constant volume. Same frequency with constant volume. A voice recorder initially at point A, okay, initially at point A at equidistance to both loudspeakers is moved by 25 meter along the line AB while monitoring the audio signal. Okay, the measured signal was found to undergo 10 cycles of minima and maxima. So, when you are moving from here to here, there were 10 cycles of minima and maxima they were observed. The measured signal was found to, okay, 10 cycle maxima minima during the movement. The frequency of input signal is. It means from here we know how much is the path length, path you can say path difference, that is 0. So if you observe 10 minima 10 maxima when you go reach B in that interval, it means this path difference has to be equal to 10 lambda. Yes, it means this length L1B and L2B, L2B minus L1B, this is my 10 lambda basically. This is the point that is mentioned here. Now you see this is 40. How much is this? This is 5. This is 5. So this is 5. This is 20. This is 20 and this is 40. And similarly, this is 40 and 20 plus 5, this is 30. So this L2B is my 50. 50 minus. What is L1B? L1B is root of 40 square plus 20 square. 20 I can take common, 20 root 5. This 10. 5 minus 2 root 5. 5 minus 2 into root 5 is given as 2.23 and this is given as lambda. Lambda I got, from there I can write my frequency as speed divided by the wavelength. What is speed? 324. So 324 divided by 5 minus 2 into 2.23. Let me do the calculations. So 2 into 2.23 and subtract this from 5.54 and this is 324 divided by 0.54. This comes out to be 600 hertz. Okay. Now some questions from gravitation. Initially, a satellite of 100 kg is in circular orbit of radius 1.5 RE. The satellite can move to a circular orbit of 3 RE by supplying this much energy. Then the value of alpha is. How we write energy of a satellite in a particular orbit? We know a ratio of kinetic is to potential is to the total energy, that is 1 is to minus 2 is to minus 1. So if I write the kinetic energy, that is half and plus with the potential energy. So what is the potential energy? GMM by R. Half of that minus GMM, potential energy minus GMM by R. Half of that is minus GMM by 2R. Take the positive sign then. So this is GMM by 2R. Like this. Like this we can write, but I think he's talking about the total energy, not the kinetic. So just write the total energy E. What is that? Minus GMM, half of the potential energy to R, like this. When you move from 1.5 RE to 3 RE, how much energy will be supplied? That is delta E. So delta E is equals to minus GMM by 2 into this is 1 by 1.5 minus 1 by 3. Clear? So that will become what it will become? Yes, that will become 1 by 1.5 minus 1 by 3. Okay, and 2 will go inside. Everything else is fine? Yes, everything else is fine. Okay. So now it is 1 by 3 minus 1 by 6 and that will become 1 by what it will become? 6, yeah, sorry, 1 by 6. Sine thing is there of radius 3 RE. Initially it was of 1.5 RE, then it is moving to 3 RE. So final minus initial, sorry, yeah, here I did mistake. Final minus initial Yeah, now it will be positive. I was thinking like why it is. Okay, so this is plus, then we'll have a plus sign, and GMM divided by 6 RE. This was RE also here. Now everything is fine. Okay, so GMM by 6 RE is there, and this energy is given as alpha into 10 to the power 6. Now put the values. Now you can multiply and divide with RE. So this will become RE square. GM by R square is 10, that is my G, this part. So this is 10 into mass of the satellite is 100 kg. RE is given as 6 into 10 to the power 6 divided by 6, and this is given as alpha into 10 to the power 6. So 10 to the power 6 are getting cancelled, and this 6 is getting cancelled, so this comes out to be 1000. This comes out to be 1000. Yes, alpha into 10 to the power 6, alpha comes out to be 1000. Okay. Next, three masses 200, 300, 400 are capped on vertices of an equilateral triangle with side 20 meter. They are rearranged on the vertices of a bigger triangle of side 25 centimeter with the same center. The work done in that process is initially, you can say, let me draw a triangle. Initially, they were at the edges of a smaller triangle, equilateral. Okay, now they are at the edges of a bit bigger equilateral triangle. Now let us take the side of the equilateral triangle as L. How we write the potential energy of the system? Three combination, this, this and this. Write the potential energy for each combination. How we write? Gm1 m2 by R. So R is same, L. So minus G by L I can take common, and then inside it will become m1 m2 plus m2 m3 plus m3 m1 like that. So this is 3 into 2 6 plus 3 into 4 12 plus 4 into 2 8 into 10 to the power 4 that I am taking as common out. This is how much? 8, 20, 26. This is minus 26 G by L into 10 to the power 4. This is as a function of L. Now your L is changing from 20 to 25. How much will be the work done? Work done is equal to change in potential energy. When you write the change in potential energy, you can take this 26 into 10 to the power 4 into G as out common. Okay, and it will become final potential energy minus initial potential energy. So 1 by 25 minus 1 by 20. Negative sign when it will go, it will be 1 by 20 minus 1 by 25. And now you can do the calculations and you will get your answer. Clear? Moving ahead. Now we are starting the 12th portion. We are starting the 12th portion. So from here, electrostatics, we are beginning. Now all the important questions from 12th portion that we are going to discuss. Let us read this question. Electrostatic potential, the electrostatic potential in a charged sphere, a region of radius r, varies with this. This is the expression for potential, where A and B are constants. The total charge in the sphere of radius this is this. Okay, the value of what is the value of alpha. Now potential is given. I can find how much is the electric field. From electric field I can find how much is the flux. From that flux I can say Q enclosed divided by epsilon naught by Gauss law. From there I can find what is Q enclosed. This is what is asked. So what I am going to do is, from V I will find what is E. Using E I will find what is F. F I will write as Q enclosed by epsilon naught. From here I will find what is my Q enclosed. This is what I am going to do. Now let us write. First V, what is V? That is V is A R Q plus B. Now from here you find E. How to find E? E is equals to minus dV by dr. So what is E? E will become minus of 3 AR square. Okay, this I got as electric field. Now use this electric field to find flux. How you will find flux? Flux is equals to area into the electric field. Now this is a spherical thing. Everywhere at a distance r, the electric field is E, and that is pointing inside. Negative sign is there. Okay, so the area is 4 pi r square. How much will be the flux? Flux will be 4 pi r square into E. E is minus of 3a r square. So this is minus 12 pi a r to the power 4. This is my flux phi. And this flux phi I will write as Q enclosed divided by epsilon naught. From there I can find how much is my Q enclosed, and this comes out to be minus 12 pi a epsilon naught r to the power 4. Pi a epsilon naught. Where is r to the power? Sphere of unit radius. Okay, r is 1. So if I put r is equals to 1, that will become 2 minus 12 pi a epsilon naught. So that comes out to be minus 12. This alpha comes out to be minus of 12. That is first option. Clear? Good. Let us move ahead. Next question. It is a question from dipole. Now two short dipoles A and B, and the charges are mentioned for the dipole, plus minus 2 microcoulomb, and then for B plus minus 4 microcoulomb, with their centers 80 centimeter apart as shown in the figure. The electric field at point P, which is equidistant from both the dipoles. Now dipole thing is very important. Like electric field from dipole is asked in mains, asked in advance, and even I don't know about boards, but in advance also many times I have seen, like recently I think there was a matrix match question where you need to, in 2024 that was there, I think. Yes, in 2024 there was a matrix match question, and yeah, matrix match question was there where two dipoles were, you know, they were placed like this, and then another they were placed like this parallelly, or they were placed like this, and then in between the field was asked. So here let us take, this is my P1 and this is my P2. Okay, it is A and B. Let us denote A with 1 and B with 2. So this is P1 and this is P2. This distances are 40 centimeter. This is also R. This is also 40 centimeter. Due to P2, this point is on the equatorial line. The field will be in the downward direction. How much? Kp2 by r cube. Kp2 divided by r cube. Due to P1, this is on the axial line. The field will be along P1, 2k P1 by r cube. Now these two, E1 and E2, they are perpendicular to each other. Take the resultant of them, root of E1 square plus E2 square. So my total field E will be root of this square plus this square. From there I can take k by r cube as common. K by r cube as common. So this will become root of P2 square plus 2P1 square. Like this. So this will become k by r cube root of P2 square plus 4P1 square. What is P1? What is P2? P1 is Q into this charge, that is into D. So P1 is Q, that is 2 into 10 to the power minus 6 into D is 1 centimeter. So this is 2 into 10 to the power minus 8. What is P2? P2 is this charge into D. So this is 4 into 10 to the power minus 8. Now K is 9 into 10 to the power 9 divided by R cube. R is 4 centimeter. Oh sorry, 40 centimeter. 40 centimeter you can write as 0.4 meter. this is my 0.4 meter. So 0.4 cube, 4 into 4, 16 into 4, 64 into 10 to the power minus 3 into P1 and P2 square are there. I can take 10 to the power minus 8 thing common out. So this 10 to the power minus 8 I am taking common. Then we are having root of P2 is 4 plus 4 into 2, that is 8. Okay. So 8 plus 4, that is 12. So root of 12 I can write as 2 root of 3. I did some calculation mistake. I think so. P2 is 4. 4 plus 4 into 2, 8. 8 plus 4, 12. A is this. Okay. A was this 2. Okay, 2. This is fine. And B was this, and this is 4 into 10 to the power, that is also fine. And then what else? What else? I think, I don't know, root 2 is there, therefore I am saying 9 10 to the power 5, 10 to the power 9, 64 into 10 to the power minus 3, yeah, 10 to the power minus 8 I took common, P2 is 4 there, so 4 plus 4 into 4 into, yeah, 4 into 4, that is 16. So this is 16 P2 square plus, and this is 4 into, that is my 4, 16. So 32, yes. So this is root of 32 basically. This will become here root of 32. Root of 32 I can write as 4 root 2. Yes, now things can be simplified. Sir, why PW don't have any English JEE batch for 2026? No, we will for 2026 because we recently started that, okay, PWJ English. We had this our series, one shot series, but for upcoming 2027 and 2028 we will launch the batches. Okay, so we are going to launch those batches for pure English. Till now we had English batches. Okay, our this platform, that is PWJ English, this YouTube channel is recently started, and we did something like we launched the Elevate JEE crash course, the one shot series that you are able to see, and we launched the mock test series also for the 2026 aspirants. So two things we did for them. Practice sheets also we provided. We did some practice sessions also online. So we tried our best because we started recently. So whatever we could we managed to do, we did. So for upcoming batches 2027 and 2028 we will launch the batches, and the details will be shared soon. What it is now? 4 into 16 and what? 9 root 2 divided by 16, 9 root 2 divided by 16, and 10 to the power will be 4, 10 to the power will be 4. This, yes, the option is there. Next question. Two charges 2q and q are placed at vertices A, the center of the face, okay, that, and that of the cube at vertex A and center of the face, that is this face, okay. The electric flux through the cube is, electric flux is equal to q enclosed by epsilon naught, q enclosed divided by epsilon naught. What is q enclosed? When some charge is there on the corner, 1/8 of that part will come inside, so 2q by 8, plus if some charge is on the face, half of that will come inside, so q by 2. Simple. Next question. 5 positive charges, each having charge q, are placed like this, okay, and we have to find the potential and field at the center. At the center, from symmetricity, I can say electric field has to be 0. Equal charges, uniformly, at same distance, at center, electric field has to be 0. What will be the potential? Each is at a distance r, kq by r from each, 5 into kq by r. 5 into q by 4 pi epsilon naught r and 0. Second option. Consider consider two identical metallic spheres of radius r, each having charge q and mass m. Their centers have initial separation 4r. Okay, initially these two spheres are there and their centers are having separation 4r, mass is m, each is having charge q. Mass is m. Both the spheres are given initial speed u towards each other. Okay. The minimum value of u so that they can just touch each other. Now just touch each other means certainly they are repelling each other because of electrostatic force. Due to gravitational force they are attracting each other, but you know gravitational force is very small as compared to electric forces. So electrostatic force you can say is too large, so they are in resultant they are repelling each other, they will be slowing down as they will come together. So just touching each other means they just touched each other and their velocities here are 0. Their speeds here in this condition both are at just at 0 speed. What will be the separation between their centers? 2r, r plus r. So this is the initial condition, this is the final condition. Kinetic plus potential here is equal to kinetic plus potential there. Simple, conservation of mechanical energy. So k1 plus u1 is equals to k2 plus u2. Now the important thing here is in the options they have considered the gravitational potential energy. So when you consider potential energy, when you write the potential energy, you need to consider both gravitational also and electrostatic also. If it would not have been mentioned, I will be considering only electrostatic potential energy, because electrostatic potential energy, electric forces are much greater than the gravitational forces. But in the options are like this, means I need to consider, therefore I will consider also. So initial kinetic is half m u square of each sphere, so into 2. Initial potential, so if I write the electrostatic potential, so kq square by 4r. If I write the gravitational, so minus gm1 m2 by r, so minus gm square divided by 4r. And finally the kinetic is 0. The electrostatic potential energy is kq square by 2r, separation is 2r now. The gravitational potential energy is minus gm square by 2r. From here you can solve for u. Next, space between the plates of parallel plate capacitor of capacitance C without any dielectric is now filled with 3 dielectric slabs. This is K1, this is K2, this is K3. And K3 is given as 5, K1, K2 is 2 and 3. If new capacitance becomes n by 3 times of C, what is the value of n? Okay, so what I will do, first of all, divide it like this. This is my C2, this is my C3. Let us write this as my C11, this is C12. These two are in series, these two are in series, this series equivalent is in parallel with that series equivalent. So they are like this. This is C11, this is C2, this is C12, this is C3. Okay. Now this series equivalent will find and then take the parallel equivalent, that will, don't say sir this and this is in parallel, first find this and then this and this in parallel and then these two parallel combination are in series. No, that is wrong, that is wrong, because this potential is actually not equal to the potential at that point. This potential is not equal to this potential, therefore these two are not in parallel and these two are not in parallel. Now C11 is, area is half, D is D by 2, so A, that is A by 2, epsilon naught, that is K epsilon naught, K is 2. So K1 epsilon naught by d by 2. By 2 is getting cancelled. So this is A K1 epsilon naught by d. This is also A K1 epsilon naught by d. This is A K2 epsilon naught by d, and this is A K3 epsilon naught by d. K1, K2, K3 is given, then you can find or let me write what is K1. K1 is 2. So 2C this is, and K1 is 2. So this is 2C. K2 is 3. So this is 3C, and this is 5C. 2C and 5C, they are in series. So the equivalent of these two, 2C and 5C, that will be this equivalent, that will be 2 into 5 divided by 5 plus 2, 10 by 7C. The equivalent of these series, 3 into 2 divided by 3 plus 2. These two are in parallel, so add them. This will become 6 by 5 plus 10 by 7 into C, and then you see, equate with that and then see what is the value of n near about. Next question. A capacitor C with first charge charged fully with potential difference V naught. Okay, a capacitor is there, it is charged with potential difference V naught first and disconnected from the battery. The charged capacitor is connected across an inductor and having inductance L. Okay, at in t seconds, 25% of the initial energy in the capacitor is transferred to the inductor. Okay, the value of t is, this is a capacitor having charge Q naught. This is an inductor. At t is equals to 0, this switch is closed. Now, at some later instant, 25% of the energy of capacitor went to the inductor. 25% of the initial energy in the capacitor is transferred to the inductor. It means Q by 4 went, 3Q by 4, 3Q naught by 4 is, no, not charge. This energy is transferred. So how the charge and energy are related? Q square by 2C. Okay, so energy is proportional to Q square. So if energy is becoming, here this my U1, okay, here I am getting 3 by 4 U1. How we relate Q? U is equals to Q square by 2C. It means my charge is becoming root of this times. So my Q dash will be root of 3 by 4Q, which is root 3 by 2Q. You know, if energy is getting 3 by 4, charge will get root of 3 by 4 times. This is LC oscillation. Initial charge was Q naught. How the charge is, this was root 3 by 2 Q naught. Okay. How the charge will change? Q is equals to Q naught cos of omega t. Why cos of omega t? At t is equals to 0, cos function is maximum. At t is equals to 0 was my charge maximum. Therefore, I wrote cos function, otherwise I will be writing sine function. Now, what is Q then? Q dash or Q, that is root 3 by 2. So, root 3 by 2 Q naught is basically Q naught cos of omega t. It means my omega t is pi by 6, cos 30 is root 3 by 4. What is omega? 1 by root LC. So, t comes out to be pi by 6 root of LC. Fourth option. Clear? Everything is okay? Okay. Good. Many of the students are not able to watch this live fully. I know, I understand that, but make sure you watch this completely after, whenever you get time, but before April attempt, because these questions are collections of important questions. Parallel plate capacitor with plate separation 5 mm is charged by a battery. Okay. On introducing a mica sheet of 2 mm and maintaining the connections of plate with the terminals of the battery, it is found that it draws 25% more charge from the battery. The dielectric constant of mica is, okay, initially the charge was Q, and LC Q is equals to CV. When you inserted dielectric, it is found that it draws 25% more charge. So here my Q dash is basically 1.25 Q, 1.25 times of Q, and this is my C dash into V. Okay, potential is same, isn't it? Capacitor is changing, C dash. So I got my C dash as this Q is CV. So put Q is CV here, 1.25 CV is equals to C dash V. So basically my C dash is 1.25. It means by inserting this dielectric, my capacitance is getting 1.25 times. Initial capacitance was A epsilon naught by D. Finally here I am having how much mm dielectric? 2 mm dielectric is there. 2 means 2 mm and the separation D was 5. So 2D by 5 is my dielectric, okay, and then 3D by 5 is my air. So this if I write C1, that is A epsilon naught by D, A K epsilon naught by 2D by 5. Like this. Let me write 5 properly here, and C2 is A epsilon naught by D, that is 3D by 5. Now these C1, C2 are in series, find the equivalent, okay, and C is my A epsilon naught by D. So find the equivalent, so that is my C dash is C1 C2 divided by C1 plus C2, and this is 1.25 times of 25 times of C. Okay, this you can write C1 as 5 by 2K into C, and C2 you can write as 5 by 3 into C. 5 by 2kc and this is 5 by 3c. So if I do C1 C2 divided by C1 plus C2, so this will become 5 by 2kc into 5 by 2c, sorry, not 5 by 2, 5 by 3, 5 by 3c and divided by 5 by 2 kc plus 5 by 3c, and this is 1.25 c, and from here you can find what is the value of k. So do the calculations, find the value of k. Moving ahead, unbalanced Wheatstone bridge. I think 2 times in April attempt this question was asked, sorry, in January attempt 2 times this question was asked, unbalanced Wheatstone bridge. Now unbalanced Wheatstone bridge are difficult to solve, certainly you can, because you know if it is balanced then it is just remove the middle resistor and then find the equivalent resistance. That is very simple. Unbalanced you have to put efforts, and there is a standard way to find it. I am going to teach you that. First of all, if this current is I1, this is I2, from symmetricity I can say this has to be I2 and this has to be I1. So here the current will be I2 minus I1, and let us take here this, I have applied the potential difference V. So my R equivalent is equals to V divided by the total current, which is I1 plus I2. This is what I need to find. Okay, so basically I have to relate I1, I2 and V. So first thing, I can move like this, and that is equals to, total drop is equals to V. So my V is equals to 6 I1 plus 3 I2. And then I can move like this, then this, like this. So that is 6 I1 minus, I am moving in opposite direction. So minus, I am writing the total drop, okay. So minus 3 into I2 minus I1, and then plus 6 I2 plus 6 I1, yeah. These two equations we got. First of all, equate them, find the relation between I1 and I2, then relate V and I1, then solve this. Let us see. 6I1 plus 3I2 is equals to 6 and 6, 12I1. 6 and 6, 12 and plus 3 also, okay, 3, 12 plus 3, 15, I1 minus 3I2. Now, this is 15I1, this is 6I1, so this I can say this is 9I1, 3 plus 3, 6I2, 3 into 2, 3 into 3, so 2I2 is equals to 3I1. Or I can say I1 comes out to be, or I can say I2 comes out to be 3 by 2 I1. This relation I got. Now put this relation here. So V is equals to 6 I1 plus 3 into I2. I2 is 3 by 2 I1. So V comes out to be 6 plus 9 by 2 I1. What it is? 6 into 2 is 12 plus 9 is 21 by 2 I1. This is my V. So V by I1 I got as 21 by 2. I need V by I1 plus I2. V by I1 plus, what is I2? I2 is 3 by 2 I1. So basically this is 2 by 5 I1. Sorry, 5 by 2, so 2 by 5 V by I1. V by I1 I got as 21 by 2. So this will become from here, okay, from here I am writing this as 2 by 5 into V by I1, that is 21 by 2. So 21 by 2, so this is 21 by 5 ohm. X by 5, X comes out to be 21. Longer way, but you can say this is the shortest method to solve unbalanced Wheatstone bridge. Shortest or only way. Okay, certainly shortest because I used the symmetry which saved some equations. So I used the symmetricity, this is I1, this is I2, therefore this has to be I2 and this has to be I1. That symmetry made it a bit, you can say, smaller, one equation. We like need not have to solve one more equation. Now we are having this Wheatstone bridge question. Let us read it out. A Wheatstone bridge is initially at room temperature and all arms of the bridge have same value of resistance R1, R2, R3 and R4. Okay, so when R3 is heated to some temperature, its resistance value has gone up by 10%. Initially all of them were R. Now R3 is heated. If R3 is heated, resistance is 10% up. It means this became 1.1 R. All are R. Certainly now this is not a Weedstone bridge. This is not a balanced Weedstone bridge. VA will not be equal to VB in this case. The potential difference between VA and VB. This potential I am considering as V. How much will be the current here? This applied potential, let me write, okay, how should I write? Let me ground this. So how much will be the current here? V divided by 2R. How much will be this current here? V divided by R plus 1.R, 2.1 R. Okay. Now write VA and VB. So if I write VA, that will be V minus, because in direction of current there will be potential drop. So V minus V by 2 R into R. So this is V by 2. Okay, V is my this, okay, this is my V. Because this is grounded, this potential becomes 40. V is basically 40. Next, if I write VB here, VB will be V minus IR, I is V by 2.1 R into 1.1 R, 2.1 R into 1.1 R, and what it is now? V minus 11 V by 21. What it is? 21 minus 11 is 10. So 10 V by 21. This is my VB. VB is there, VA is there, I need VA minus VB. So VA is V by 2 minus VB is 10 by 21 into V. Okay, so this is my VA minus VB, and this V is 40, so this is 40 into 1 by 2 minus 10 by 21. This is my VA minus VB. Now do the calculations. K Kusam, hello. Moving ahead. Next question. Two resistors 2 ohm and 3 ohm are connected in gaps, okay, of bridge as shown in the figure. The null point is obtained with the contact of jockey at some point on the wire xy. When an unknown resistor is connected in parallel with 3 ohm, the null point is shifted by 22.7 centimeter, 22.5 centimeter. Initially, total is 1 meter. Okay, the ratio, this 2 divided by this length has to be equal to this 3 divided by this length. So I can say this length will be 40 and this length will be 60. Then you connected a resistance in parallel with 3 ohm. So this resistance was 2 ohm. You connected a resistance R in parallel with 3 ohm. So this resistance will become 3R divided by R plus 3. Okay. And this length, certainly that second length will decrease. And how much it decreased? By 22.5. So first will increase by 22.5. How much it will become? 40 plus 22.5 is 62.5. 40 plus this 22.5, that is 62.5, and the second one will become 60 minus 22.5. So that is my 40 minus 2.8, that is 37.5. 37.5. Now 2 divided by this has to be this resistance by that length, simple thing. So 2 divided by 62.5 is equals to this resistance is 3R divided by R plus 3 divided by this, that is 37.5. Okay, so from here you can find what is the value of R. Clear? Great. Now we are having a break. Okay, this is, how much is the time? This is 8:52, 8:32, sorry. So we are taking a break of 8 minutes. We'll be back at 8:40. So we are back, students. Okay, let us solve this question. What it is? Two cells having same EMF E and internal resistance R, the current passing through the external resistance 6 ohm is same when both cells are connected either in series or in parallel. So whether you connect in series or you connect in the in parallel combination, the current is coming out to be the same. So you can write like first it is connected like in series. Okay, this is my external resistance R, EMF R, internal resistance R, EMF E, sorry, internal resistance R. So the current here will be total EMF divided by total resistance, that is 2R plus R. Now you are connecting these two cells in parallel. First of all, write the parallel equivalent, R equivalent and E equivalent. How we write the R equivalent? 1 by R equivalent is equals to 1 by R1 plus 1 by R2, and therefore R equivalent comes out to be R by 2. Then write the E equivalent. So E equivalent divided by R equivalent is equals to E1 by R1 plus E2 by R2. Simple thing. So my E equivalent is coming out to be E only. So E equivalent is equal to E. So here E equivalent is E and R equivalent is R by 2, and this is my resistance R. So here if I write the current I, this will be E divided by R plus R by 2. So these two currents are equal. So 2E divided by 2R, or I can write this as divide numerator and denominator by 2. So E divided by R plus R by 2 is basically equal to E divided by R plus R by 2. This got cancelled. R by 2 is capital R by 2. So this R comes out to be R. So the internal resistance is coming out to be the external resistance, that is 6. Clear? Next question. Here a wire of uniform resistance lambda ohm per meter is bent into circle of resistance R. Okay, another piece of wire with length 2R is connected like this, shown. Okay, the equivalent resistance between point A and base. Now these three resistance are in parallel. This resistance, this is R1, this total resistance, that is R2. Okay, so let me write it clearly. So this resistance R1, this total resistance from here to here, this is R2, and this resistance R3. They are in parallel. What is R1? Lambda, resistance per unit length, into this length. What is this length? Angle is pi by 2. So pi by 2 R. Pi by 2 into what is the radius? Small r. What is R2? This total length is 2R. So 2R into lambda. What is R3? This total length is 3 pi by 2 into R into lambda. And then find the R equivalent. So 1 by R equivalent, because these three are in parallel, 1 by R1 plus 1 by R2 plus 1 by R3. From there you can find what is the value of R equivalent. I'm moving ahead. Next question. Two identical circular loops P and Q, each of radius R, are lying in parallel planes such that they have common axis. The current through P and Q are I and 4I. Okay, so here we are having current I and here we are having current 4I, respectively in clockwise direction as seen from O. Okay, so if you see from O, the direction is clockwise, means you are seeing from here, it will be clockwise like this. Okay, clockwise like this. So due to this, the magnetic field will be in this direction, that will be in this direction, B1. I am taking this as 1. And when you, okay, this was clockwise like this, so magnetic field will be in this direction. So here if you see this second one, this is also clockwise, so the magnetic field will be in this direction, B2. This is my loop 2. Okay, the net magnetic field at O is, so net will be B1 minus B2, okay, or B2 minus B1. B2 is greater, yes, yes. So net will be in this direction, that is B2 minus B1. How we write the magnetic field on the axis? B, that is mu naught I r square divided by 2 into r square plus x square to the power 3 by 2. This is how we write. And here this radius is also r, this radius is also r. So if I write B1, current is I there. So mu naught I divided by 2 into, this will be 2 to the power 3 by 2, that is 2 root 2. So this will be 4 root 2 here. 2 root 2, okay, so that will be 4 root 2 into 1 r will remain there. Yes, this is my B1, and B2 if I say, so this current is 4 times of that, so 4 times of mu naught I by 4 root 2 r. The difference will be 3 times of mu naught I by 4 root 2 r, and that is towards Q. Second option. 3 long straight wires are arranged mutually parallel as shown. The force experienced by 15 centimeter of length Q is. Okay. So parallel wires attract each other, and if the current is anti-parallel, then they will repel each other. So due to this wire, the force will be in this direction. Let us say that is F1. Due to this wire, it will attract. So this force will be in this direction, F2. So total force will be summation of F1 plus F2. How we write force between two parallel wires? We know force per unit length. Mu naught I1 I2 divided by 2 pi d. This is how the formula is. We know that. So when you write F1, this will be mu naught into I1 I2, 3 into 1, that is 3, divided by 2 pi into d is 3 centimeter, plus here mu naught by 2 pi into I1 I2 is 2 divided by d is 2 centimeter. Now you do the calculations and you will get the answer. Clear? Easy? Easy to understand? Not easy to understand. Why? Because this is force per unit length. You need to multiply the length also, that is 15 centimeters. So into 0.15, that will be your answer. Okay, yeah. I'm moving ahead. A short bar magnet placed with its axis 30 degree with an external field of 800 Gauss experience a torque of this much. How we write torque? Torque we write as M cross B. This is how we write. This is MB sine theta. This tau, what is the tau? That is 0.016. This is MB into sine of 30. Sine of 30 means 1 by 2. Sine of 30 means 1 by 2. So MB comes out to be 0.032. Getting it? Next. The work done in moving it from most stable to most unstable position. Work done is equals to change in potential energy. So when I'll write work done, this is equals to change in potential energy. Most stable. Stable means least potential energy. Okay, how we write the potential energy, by the way? Potential energy is minus mb, m dot b, so that is minus mb cos theta. Most stable will be when cos theta is 0, cos theta is 1, minimum potential energy minus mb. Means you are moving from parallel to the magnetic field to the anti-parallel to magnetic field. When I write the work done, that is my final potential energy, that is mb, minus initial potential energy, that is minus mb. So this is twice of mb. What is mb? mb is 0.032. So the work done comes out to be 0.064 joules. So 64 into 10 to the power minus 3. Clear? Great. Next. A conducting circular loop is rotated about its diameter at a constant angular speed of 100 radian per second in a magnetic field of 0.5 Tesla perpendicular to the axis of rotation. when the loop rotates by 30 degree from horizontal position, the induced EMF is this, the radius of the loop is. Let us take this side view of the loop. Okay, this is the side view of the loop. This is horizontal when it is making 30 degree with horizontal. Or let us take in general when this theta is there. What will be the flux? Flux is equals to B dot A. B is in which direction? Perpendicular to the axis of rotation. Yeah, where it is mentioned, perpendicular to the axis of rotation. Okay, so axis of rotation is like you can say the magnetic field is in this direction B. My area vector will be in this direction perpendicular to the plane A. This is theta, this is 90 minus theta, this is also theta. So my flux here is basically BA cos of theta, and theta as a function of time you can write as omega t. So flux is basically BA cos of omega t. You want induced EMF d phi by dt. So induced EMF minus d phi by dt. So differentiate it. So minus BA is constant. Cos omega t differentiation is minus omega sin omega t. Okay, so minus omega sin omega t. So this becomes BA omega sin omega t. When omega t is 30, this EMF is given like this. Radius we know. So BA omega sin 30 is given to us as 15.4 into 10 to the power minus 3. B is given as 0.5 Tesla. So 0.5 into area you can write as, this is circular loop, so pi r square, sin 30 is 1 by 2, this is 15.4 into 10 to the power minus 3. So from here you can find the value of r. I'm moving ahead. Next question. A 1 meter long metal rod, what it is? Yes, 1 meter long metal rod AB completes the circuit as shown in the figure. The area of the circuit is perpendicular to magnetic field, and magnetic field is given like this. This is the magnetic field. If the resistance of the total circuit is 2 ohm, then the force needed to move the rod towards right with constant speed V is 1.5 meter per second. And how much is that force? Constant speed V 1.5 meter per second. How much will be the force? Okay, as we are moving it towards the right, the flux that is inside the plane is increasing. Therefore, the current will come such a way that it will reduce. So the current will come like this. Current is like this. If current is like this, there will be magnetic force, that is IL cross B. So a magnetic force will be in this direction. So you need to apply an external force F such that the acceleration is 0. This will be BIL. How much will be I? I is equals to induced EMF divided by the resistance. What is induced EMF? BVL divided by R. What is B? 0.1. What is V? 1.5. What is L? 1. What is the resistance? That is 2. You got I? From here you will find how much is the force. Easy to do calculations? I am moving ahead. Next question. Figure shows the circuit that contains 3 resistors 9 ohm each, 2 inductors 4 millihenry each. The reading of ammeter at the moment when switch is turned on is. So you just turn the switch. Inductor at t is equals to 0 will behave like an open circuit. Yes. Inductor at t is equals to 0 will behave like an open circuit. So here the current will be 0 and here also the current will be 0. Initially only I am talking about. So the current I will go like this. You move in this loop, you will say I is equals to V by R. So that is 9 by 9 is 1 ampere. Clear? Next. Okay, this is a series RLC circuit. For the series LCR circuit connected with 220 50 Hertz source as shown in the figure, the power factor is A by 10. What is the value of alpha? So just draw that impedance triangle first. XC minus XL. This is our find phi. Okay. How much is XC minus XL? XC minus XL is 70 minus 150. Sorry, 150 minus 70, that is 80. What is R? R is 60. How much is this angle? This angle is 4 by 3. 10 inverse of 4 by 3 is 53 degree. Cos 53 degree is 3 by 5. Because power factor is basically cos of phi. I got my 10 of phi, that is 80 by 60, that is 4 by 3. From here I got my phi to be 53 degree. Cos 53 is 3 by 5. So this is 3 by 5, which is given as alpha by 10. So alpha comes out to be 6. Alpha comes out to be 6 in this case. Clear? Good. An inductor stores 16 joule of magnetic field energy and dissipates 32 watt of thermal energy due to its resistance when a AC current of 2 ampere and frequency 50 hertz flows through it. The ratio of inductive reactance to its resistance is. Okay. So stores 16 joule of magnetic field energy. So half L I square is 16 and dissipates 32 watt of thermal energy due to resistance. Thermal energy dissipated I square R, and that is given as what is that? 32 watt. That is 32. Take the ratio. I square getting cancelled. This 1 by 2 and this 2 is getting cancelled. L comes to be R. L comes out to be R. I need the ratio of inductive reactance and resistance. I need the ratio of XL by R. XL is omega L divided by R. What is omega? Omega is 2 pi F into L by R. What is L? That is equal to R. They are getting cancelled. 2 pi into how much is the F? F comes out to be 50. So 100 pi means 314. Okay, next. A plane electromagnetic wave is moving in free space. The speed is given, the electric field is given, the magnetic field B will be. Okay, how to write magnetic field? First of all, write the amplitude. B naught is equals to E naught by C. This relation we know. What is E naught? 54. So write it. 54 divided by 3 into 10 to the power 8. Okay, so 3 into 1. Okay. And 8. Okay, so this is 1.8 into 10 to the power minus 7. B naught I got. Then this term will be as it is. Direction of propagation is plus z. So wave is going along plus z axis. Plus z means k cap. Okay, it means my E cross B has to be in direction of z axis. What is the direction of E? This is along j cap. Okay, so j is y. So my y cross how much? Okay, I need k cap na outside. Okay, y cross minus I, isn't it? J cross minus I. So B has to be along minus I. Then only we will get this as k cap. So B has to be along minus I. Now you write the equation. So 1.8 into 10 to the power minus 7. Everything else will be same. So sine of this kz minus omega t. Then give the direction, that is minus of I. Now match the options. SI unit Tesla. Clear? Next, radio. Okay, this is application. So radio wave, how the radio wave is generated. Okay, how they are produced. So microwave is produced by magnetron. So B we are getting 1. Radio waves are due to rapid acceleration of electrons. Yes, 4th. Infrared are due to change in the vibration modes. Okay, due to the vibration, okay, because it's a thermal energy. So this is due to the vibration. Second, and X-ray, these X-ray, you know, this due to inertia of the electrons moving from higher energy level to lower energy level. So that will be my characteristic X-ray. So you know, higher energy level, they will come to the lower energy level, then a characteristic X-ray is emitted. Yes. So 3, 4, 1, 2, 3. Third option. Next, a microscope. In a microscope, objective is having focal length this, eyepiece is having focal length this, the tube length is this. The magnification produced by this microscope for normal adjustment. Normal adjustment means image at infinity. Okay, so magnification is LD by F naught FE. This is for infinity. And at D, okay, if I talk about at D, then this formula becomes L by F naught into 1 plus D by Fe. In my one shot recently uploaded, I have shown the derivation, so you can check the derivations also. So now I need this. Okay, so here we need this. What is L? L is tube length 32. What is D? 25 divided by F naught is 2 into F eyepiece is 4. This is 8 into 4. This is 100. This comes out to be 100. Next, a biconvex lens is formed by using two thin plano-convex lenses as shown in the figure. The refractive index and radius of curvature are also mentioned in the figure. Okay. When an object is placed on the left side of the lens at a distance of 30 centimeter from the biconvex lens, the magnification of the image will be. So first of all, we need to find how much is the equivalent focal length. Once I get my equivalent focal length, I will find how much will be the magnification. Okay, just I need equivalent focal length. So for this first half, I can say focal length is F1. For this, I am taking focal length as F2. Now first of all, let us write what is F1 and F2. So 1 by F1 is equals to mu minus 1, 1.5 minus 1 into 1 by R1 minus 1 by R2. So 1 by 15, this is plus, okay, minus R2, that is flat surface, infinity. Similarly, 1 by F2, if I write mu minus 1, 1.2 minus 1, okay. So 1.2 minus 1 into 1 by R1, so 1 by infinity minus 1 by R2, R2 is minus of that, so plus 1 by 12 like that. Okay, so you got 1 by F2. From here find F equivalent, that is 1 by F1 plus 1 by F2. Then you use the lens formula, 1 by V minus 1 by U is equals to 1 by F. So my V I'll find, U is given as 30. Yes, minus of 30 is equals to F, I'll use as F equivalent. From here you will find V. Then magnification is V by U. You will do the calculations and you will find how much it is. I'm telling you the process. Next, the exit surface of a prism with a refractive index n is coated with a material having a refractive index n by 2. Okay. When the prism is set to for minimum angle of deviation exactly meets the condition of critical angle. What is happening here is, here we are having medium of refractive index n by 2. Prism is having refractive index n. Light is coming, go like this. This is R1, this is R2. At minimum angle, minimum deviation, R1 and R2 both are equal to R. And this R2 happens such that it happens TIR here. Okay, R2 is theta critical for that. R2 is basically theta critical. I can say sin theta critical is equals to 1 by the refractive index of denser divided by refractive index of rarer. Okay, what is denser? N divided by n by 2. Okay, n divided by n by 2, like this. So this became 1 by 2. So theta critical comes out to be 30 degree. So R2 comes out to be 30 degree. If R2 is coming out to be 30 degree, R1 is also 30 degree. What is this angle? Angle of the prism? Angle of the prism is R1 plus R2. 30 plus 30, that is 60 degree. So this comes out to be 60. First option. Clear? Great. Next, thin convex lens of focal length 5 cm and thin concave lens of focal length 4 cm are combined together without any gap. So convex lens, focal length is 5 cm. Then my concave lens, here the focal length is 4 cm, certainly with sign I'll say -4. Okay. Okay, and this combination has magnification m1 when an object is placed at 30 cm before the convex. Sorry, 10 cm. So this is 10 cm. Here my magnification is m1. So let us do the calculations quickly. First of all, I'll find the equivalent focal length. These two are in contact. So 1 by f equivalent is equals to 1 by f1 plus 1 by f2. f2 is -4. So this comes out to be -1 by 20. So f equivalent comes out to be -20. Now use the lens formula. 1 by v minus 1 by u. U is minus of 10. So plus 10 is equals to 1 by f. So this is -20. From here 1 by v comes out to be -1 by 10, -1 by 20. This is -20 there. 2 plus 1, that is 3. So v comes out to be minus of 20 by 3. Find magnification m1. M is v by u. So m1 is equals to v is -20 by 3 by, what is u? U is -10. So this comes out to be 2 by 3. This is our m1. m1 I got. Now second case. Second case is keeping the positions of the convex lens and the object undisturbed. The gap of 1 cm is introduced between the lens by moving concave lens away. So I moved this concave lens away now. These two lenses will not be in contact now. This is 1 cm. The object is at 10 cm here. Okay, will lead to change in magnification of total lens m2. What is the value of m1 and m2? Okay. Now find m2. So how to find m2? First find magnification due to first lens, then find magnification due to second lens, multiply the two. Due to first lens, this is at 2c. So the image, first image will be at 2c on the other side. Here the image will be. So due to this second lens, this image, this object will be here at this 9 cm. Due to first lens, the magnification will be -1. We know. M1 here due to this. M21. This is -1. Now M22 we need to find. How? The object is at plus 9 towards the right. 1 by v minus 1 by u is equals to 1 by f. 1 by v minus 1 by u is 9 is equals to 1 by f, that is -4. From there I'll find what is my v. So this 1 by v comes out to be 1 by 9 minus 1 by 4. What it is? This is 36. This is -5. This is 1 by v. Then magnification is v by u, just magnification, that is v by u. What is v? V is minus 36 divided by 5 divided by, what is U? U is plus 9, yes, plus 9 there. You think चलेगा आधा घंटा 30 minutes 40 minutes और लगेंगे? हाँ कोई नहीं. Okay. Then it is 9 into 4. 9 into 4. This is minus 4 by 5. This is my M22. Total magnification M2 here is the product of the two, minus 1 into minus of 4 by 5. Okay, so this comes out to be 4 by 5. And I need ratio of M1 by M2. Now take the ratio of M1 by M2. M1 by M2 is equals to 2 by 3 into 4 by 5. This comes out to be 5 by 6. Okay, now none of the options are matching here because this question was dropped by NTA, but I considered this because this was a good question. In a Young's double slit experiment, the two slits are kept at 0.4 mm apart, okay, and the screen is placed at 1 meter from the slits. If a thin transparent sheet of thickness 20 micrometer is introduced in front of one of the slits, then central bright fringe, it should be central. Central bright fringe shifts by 20 mm on the screen. Okay, these are the two slits. Initially, you can say here the central bright fringe will be there. Now, what you did, you introduced one slit in front. You can say what, transparent sheet in front of one of the slit, due to which this path length effectively increased. So here, somewhat like this central maxima will shift. By how much it will shift? Let us take this as y. Due to shift, whatever is the path difference, that will be equal to the path difference introduced due to this slit. How much will be the path difference introduced due to this sheet? That is mu minus 1 into t. So mu minus 1 into t is equals to, how much will be the path difference introduced due to this shift? That is d sine theta dy by d. This is what we have to do, and the refractive index of the sheet we can find from here. What is t? This is 20 micrometer. Okay, so mu minus 1 into 20 into 10 to the power minus 6 is equals to, what is small d? The two slits separation 0.4 mm. So 0.4 into 10 to the power minus 3 into, what is y? Y is 20 mm. So 20 into 10 to the power minus 3 into d, the separation between the slits and the screen, that is 1 meter. So 1. From here you can find what is the value of mu and do the calculations. Now moving ahead, in the Young's double slit experiment, the intensity produced by each one of the individual slits is I naught. Okay, the distance between two slits is 2 mm. The distance of screen and the slit is 10 meter. The wavelength of the light is given. The intensity of the light on the screen in front of one of the slit is. In front of one of the slit means here. What will be the intensity? Okay, how we write the intensity? If the path difference between the two, or the phase difference between the two is phi, so my resultant intensity will be 4 I naught cos square phi by 2. This is how I can write, because both the intensities are same. Or you can write this formula in other way, because I know I is equals to I1 plus I2 plus 2 root I1 root I2 cos of phi. This is also how we can relate the two. I1, I2 is I naught, so if you put the two things are actually the same. Now, what is phi? This is what I need. Phi, or my phase difference, is equals to 2 pi by lambda into delta x. This is how we relate with the path difference. What is delta x? delta x is equals to d sine theta dy by d. Now write it, 2 pi divided by lambda is 6000 angstrom, so 6000 into 10 to the power minus 10 into small d, the distance between the two slits is 2 mm, so 2 mm into y, that is also, this is my d by 2, so 1 mm divided by capital D. Capital D is the separation, this, that is 10 meter, that is 10. So 10 to the power 4, 1, okay, so minus 6 and this, okay, and then this 2 into 3. So this comes out to be 2 pi by 3, that is 120 degree, and if you put that 120 degree here, it comes out to be I naught. 4 I naught cos square of 60. That will become 4 I naught into 1 by 4, that comes out to be I naught. Is this point clear? Please mention if that is clear to you. Next, which of the following are true for single slit diffraction? Width of the central maxima increase with decrease. Okay, so we need to see what we need to see. We need to see the width of the central maxima for diffraction. Okay, so how we write basically? So let us take, this is my slit. Okay, so central maxima will be from upper first minima to lower first minima. Minima comes out at an angle sin theta lambda by a, isn't it? Sin theta lambda by a. So first minima and lambda by a. Okay, so first minima will be at sin theta lambda by a. Theta is very small anyway, sin theta is theta, and here downward first minima is also lambda by a. So central maxima will have a total width of 2 lambda by a, angular width. Okay, now if you ask me how much is this width, so 2 into lambda by a into this separation between the slit and the screen, that is d. So basically I got my width as w, which is 2 lambda d by a. Now width of central maxima increases with increase in wavelength, keeping slit width constant. This is true. This is true. Second, width of central maxima increases with decrease in wavelength. No, this is not true. Width of central maxima increases with decrease in slit width. Decrease in slit width. Yes, this is true. This is not true. Brightness of central maxima increases for decrease in wavelength at constant slit width. This is also true. Now you may say, sir, how E is true? How this E is true? Okay, that I'll show in the derivation actually. So this is a bigger derivation. There we get some intensity expression, okay, and there this expression, there we see that actually with increase in lambda, that brightness, the intensity actually increases. Okay, clear? Moving ahead. Which option it was, by the way? I think none of them was matching. Here A, C and E. A, C and E. Okay, now this is corrected, I think. And this was a mistake. Next is the average energy released. Hello everyone. I'm Mittal. Hello. The average energy released per fission for nucleus is this: when all the atoms of 47 gram, okay, pure 235 uranium undergoes fission, the energy released is this. What is the value of alpha? So first of all, see how many atoms are there. So number of atoms will be number of moles, that is 47 divided by 235 into Avogadro number, that is 6 into 10 to the power 23. These are number of moles, okay, number of particles. Each particle will give us 190 mega electron volt. That's all. Okay, this much will become my total energy. Number of particles into the energy released due to each particle, and this is in mega electron volt. And here also it is a mega electron volt. So just do the calculations. I got 100 percentile. Okay, anyways. An atom X83 is bombarded by a shower of fundamental particles. In 10 tenths of this atoms are absorbed, okay, 10 electrons, 10 protons, 9 neutrons in 10 seconds, okay, sorry. In 10 seconds, it absorbs these many particles. The percentage growth in surface area is, so how we relate the surface area of nucleus with radius? Surface area is 4 pi r square. Radius is related with mass number as r naught to the power a by 3. R naught into a to the power 1 by 3. This is how we relate. So, surface area if I write as, that is 4 pi r square. So, my surface area is basically proportional to a to the power 2 by 3. Initially, the mass number was 8. So, S1 proportional to a to the power 2 by 3. Finally, mass number becomes 8 plus 10 plus 9. Add protons and neutrons only, because inside the nucleus protons and neutrons are there. 19 plus 8, that is 27. So, 27 to the power 2 by 3, divide them. So, S1 by S2, what is 8 to the power 2 by 3? That is 4, divided by 3 to the power 2, 27 to the power 2 by 3 is 9. So, this becomes my S1 by S2. Now, you can find how much is the percentage increase simply from here. The binding energy for the following nuclear reaction are expressed in mega electron volt like this. If x3, x4, x5 denote the stability of this respectively, then the correct order is stability is higher when greater energy is released, because if forming that nucleus releases more energy, it means if you have to break that nucleus, it will also need more energy. Okay, so greater the energy released, greater the stability is. From H3 to H4, which is more stable? He4 is more stable because 20 mega electron volt is released. So, He4 is more stable. From He4, between He4 and He5, which is more stable? He4 is stable because here it is absorbing energy. So, He4 is more stable, but here stability differences, you can say very less, because this energy is very less. So, highest stability is for He4, then He5, then He3. So, 4, 3, 5. Sorry, 4, 5, 3. Yes, 4, 5, 3. Two electrons are moving in orbit of two hydrogen-like atoms with speed this and this. If the radii of these orbits are nearly same, then possible order of energy states is. How we relate radii? Proportional radius we write as r is equals to r naught into n square by z. Speeds are given, v is v naught into z by n. Okay. So, v1 by v2 if I take, that is z1 by n1 into n2 by z2, and this ratio is 3 by 2.5, that is 6 by 5. Then the radii are nearly the same. Okay, radii are nearly the same. It means n1 by z1, sorry, it means n1 square by z1 is equal to n2 square by z2, and n1 by z1 divided by n2 by z2 is 5 by 6. Take this other side, n1 by z1 divided by n2 by, or how should I say, n1 by z1 is equal to n2 by z2 is equal to 6 by 5 times of n1 by z1. So, 1 n1 by z1 will get cancelled here. Okay, so this will become n1 and this will become n2. So, n1 by n2 comes out to be 6 by 5. So, therefore, this is 6 and 5. You are a great teacher, please bring more sessions like this every day. Students are not coming to this session also because boards are there, so they have hardly any time to attend such sessions, but still we are doing because students will watch this in recorded form at least. This is conclusion of the April attempt session. Okay, all the important questions, set of all the physics important questions, okay, are there. So at least I am recording this such that students will take benefit, because I want you to like revise all the questions from the April attempt. But if you don't have time, okay, so all the important collection you'll see here. Watch this session, that is covered now. The smallest wavelength of Lyman series is this. The difference between the largest wavelength of Paschen and Balmer series is nearly. So smallest wavelength of Lyman, smallest means highest energy. So it will go from infinity to 1. Okay, that is 91. So infinity to 1. So 1 by lambda is equals to 1 by r into 1 by n1 square minus 1 by n2 square. So 1 minus 0. So from here I got my r 1 by lambda. Okay, anyways I can say 1 by lambda is equals to r, and that lambda is given as 91 nanometer. 1 by r, that is given as 91 nanometer. The difference between the largest wavelength of Paschen, largest wavelength Paschen means it should come to n is equals to 3. Lyman, Balmer, Paschen. Largest wavelength means least energy, so 4 to 3. Largest for Balmer, Lyman, Balmer, so 3 to 2. So here if I write 1 by lambda is equals to r into 1 by 9 minus 1 by 16 lambda 1. Okay. Similarly here 1 by lambda 2, if I write this is r into 1 by 4 minus 1 by 9, and then you subtract what I need, the difference na, just you subtract these two, lambda 1 and lambda 2. So first of all 1 by lambda 1 will come out to be 7 by 144 r, and 1 by lambda 2 is r into 5 divided by 36. Okay, so lambda 2 and lambda 1 difference you can take from here, and then you can relate with how much relate with this lambda, that is 91. You can use that calculation and you can solve it. Okay, I am leaving it here, this calculation. You are great, sir. Thank you. When a light of a given wavelength falls on metallic surface, the stopping potential of photoelectrons is this. If the second light of wavelength twice the first light is used, the stopping potential drops to 0.7 volt. How we relate? The kinetic energy is equals to hc by lambda minus phi, and this we write as E into V stopping. Initially V stopping is 3.2. So hc by lambda minus phi is equals to 3.2 E. Second, the wavelength drop to half. Okay, the wavelength becomes twice. So hc by 2 lambda minus phi, this comes out to be 0.7 E. The wavelength of the first light is, so we need lambda from here. Okay, so you can solve these two equations, substitute phi from first equation to the second equation, and then you will be able to get the value of lambda. Clear? Next, the de Broglie wavelength of oxygen molecule is this. The value of x is, okay, how we relate de Broglie wavelength, by the way, lambda is equals to h by mv. This is how we write. What is v? RMS speed, okay, root of 3 RT by m. M is molar mass, but write in terms of molecular mass, because here m is molecular mass. So you can write this as root of 3 kT by m. Now substitute is lambda is equals to h divided by m into root of 3 kT divided by m. So this comes out to be h divided by root of 3 kT and m. In this question, the molecular mass is given, K is given to us, H we know, and the temperature is given. Convert this to SI by adding 273. Okay, this will become 300 Kelvin. So you'll use temperature there and you'll get the answer. Next, logic gate question. Find the correct combination of ABCD inputs which causes LED to glow. For LED to glow, it should be in forward bias. For this LED to be in forward bias, this should be 1 and this should be 0. CD, this is you can say not of OR. So what it will be? This will be C plus D bar. This is C bar into D bar. If C bar into D bar is 0, it means either of them should be 1, C or D, or both can be 1. So C, D, I can say if this is, it can be 0, 0, it can be 0, 1, it can be 1, 0, not 0, 0, sorry, not 0, 0, both of them if 0, then it will become 1, isn't it? 0 bar 1, 0 bar 1, 1 into 1, 1. So it can be 0, 1, it can be 1, 0, it can be 1, 1. These are the possibilities. From top, this has to be 1. This is A bar, this is B bar, this is NOR gate, okay. Then I can say this is A bar plus B bar whole bar. Is it clear? Yeah. A bar plus B bar whole bar. So this will be A into B. My A into B is 1. So both should be 1. A should be 1 and B should be 1. I think there is some mistake in the diagram in this question. Let me check again. Let me check it quickly. I think there is something that is missing in this question. The diagram. Just checking it. Yeah. The missing thing is this was AND gate. Yeah. Got it. This was AND gate. This was an AND gate. So this is A bar into B bar. So A bar into B bar has to be 1. So what is the possibility? Both are if 0, I think that is the only possibility, if both are 0. Yes. A bar should be 1, B bar should be 1. So A should be 0 and B should be 0. Therefore, that will be 1. So we are having 3 possibilities: 0, 0, 0, 1 or 0, 0, 0, 1, 0 or 0, 0, 1, 1. So first 2 has to be 0, 0. So 0, 0 and then we are having 1, 0. That is a possibility. Yes, this is correct. Okay, only in this option first 2 are 0, 0. In none of the other options they are 0, 0. Clear? Next. 2 p-n junction diode D1 and D2 are connected like this. A and B, C are the output. Okay, the given circuit will function as which type of gate? Okay. Now we will check for all the conditions. This is AB. So let us put 0, 0, then 0, 1, then 1, 0, and then 1, 1, and then we will see what is my output. C. Okay. If what is C? C is the input signal and C is the output. Okay. If any of this is 0, this will become forward bias and the output will be 0. If any of this is 0, the output will be 0. If both are 1, these will be reversed bias, the output will be high. So this is AND gate. This is an AND gate. Both should be 1 for the output to be 1. Last question of the discussion. A voltage regulating circuit consists of Zener diode having breakdown voltage of 10 volt and maximum power dissipated 0.4 watt. Okay, is operated at 15 volt. The approximate value of protective resistance in the circuit is. So let us draw the Zener diode circuit. This is my load resistance. This is my protective resistance. So this is 10 volt. This is 15 volt. So this is 5 volt. Maximum power dissipation across the Zener diode can be 0.4. So how much can be this maximum current? So power is equals to V into I. So 0.4 is equals to Vz into Iz. Vz into Iz. So what is Vz? Vz is 10 into Iz. So this is 0.4. So Iz comes out to be 40 milliampere. Now this is 40 milliampere. I need to protect this Zener diode by this resistance. Okay. Now even if this load resistance is, let us take, now here what will be the current, by the way? This current can be either 40 or greater than 40, yes? It can be either 40 or greater than 40. Let us take this current is I. I need this resistance, so I'll say this resistance is equals to V by I, 5 by I. The maximum possible value of resistance should be there such that it protects in all the conditions. Therefore, I will consider the minimum possible value of I. For that minimum possible value of I, if it protects, then it will be always protected. What is the minimum? 40, isn't it? Yes, when IL tends to 0. Okay, so 5 divided by 40 milli, it is milli, so 10 to the power 3 will go in the numerator. So how much it is? This is 500 divided by 4, 125 ohm. So 125 ohm is the answer. So these are the questions that we discussed, and make sure you watch this complete video after whenever you get time, because you are busy in the boards currently, so I can understand if you are not able to come in the live, but make sure you don't miss any part of this video, because this gives you the grasp, means you can say brief, not brief, the complete understanding of the type of the questions, the level of the questions, the topics that were asked in April attempt, so in January attempt 2026. So that will make you actually prepare or ready for the April attempt. So thank you all for attending this. Bye. If you have any doubts, you can mention in the comments. I'll get back to you. Thank you.